Hey guys, how's it going? I am just adjusting some stuff over here. Hope everyone's doing all right. Langors, what's up? It's going pretty good over here. And Kirkix, how's it going? I have no idea if I'm saying our username right too. Every time I see that, yeah, I don't know what to say with the XXX at the end. But it's good to see you guys. Charlie Pyre, how's it going? Good to see you. So today the plan is we're gonna get some block drops up, hopefully. Before we can do that, we got to fix a couple things from the last stream. I have not been able to touch this code at all. Been quite busy at work. I've got like a big feature launch April 19th, and I'm pushing to finish that. So I have been spending a lot of time on that. And then also that video for textures that's going to be on YouTube next. I am still trying to finish that. So just got some things going on, but hopefully we can get some stuff done today. So first of all, we got to fix the ambient occlusion. If you remember from the last stream, it was broken, if you guys were here. And Still Tree, how's it going? I think most of you guys were here. But yeah, so we kind of broke the ambient occlusion. We got to fix that. The stairs are completely broken. I think that's probably the most egregious thing. So why don't we fix the other block models first, and then we can get around to fixing all this stuff. And one of the exciting things, you'll notice I have a bunch of these stupid wood block textures and whatnot. The reason I have those there is because it's really hard to, I don't have any way to render these extra blocks. So like a sandwich block, you know, I don't have a way to render that easily. And so hopefully with this new method, since we're going to have block drops, we're going to have a way to render blocks easily. And then what I can do is the same thing I've done here, which is basically render an image, and then we can use that for the block icons down here. Because basically what happens to generate those icons, what we do is we generate, I basically just go through and draw all of them, and then we generate this image, which is just like a sprite sheet with all the block icons. So once we get those working, we can hopefully generate the rest of the icons and get that stuff all good. So yeah, let's fix up those stairs real quick. Should be pretty easy. Assuming our stuff still works right, let's go into VS Code, because that's where we got all those definitions there. Yep, the sandwich is still there. Don't worry. Have not removed it. I've been thinking too. I'll talk about some of my thoughts on like possible improvements we could make to get like better colors and stuff in game, and possibly design blocks in game. We'll talk about that a little bit later though. I'm still kind of tossing it up and don't quite know what I want to do. This is for the next video. Sneak peek, I guess, of the code that I'm using to write. 1,500 lines, guys, okay? It's just so much. Okay, let's go to here. This is what we want. Okay, so we want this stairs model to basically work by doing that. And then we can get rid of all of this. So let's do that. Which means we should be able to go to Blender, open that up. We have a file inside of here. Yes, okay. So we got this models.blend. If we open this up, we can go ahead and just like quickly design out that stair block, and then we can get that. HDR support. What do you mean by that? Like a HD rendering pipeline or something, or something else? I have no idea what you mean by HDR. I know there's like a HDRP or whatever, which is like high definition rendering pipeline or whatever. I don't have anything like that. There's nothing special going on, but yeah. Hilbert Curve, how's it going? Okay, so let's go ahead. We'll duplicate this. I think it's Control D. No, that did not work. How do you duplicate? Control C, Control V. That works. Okay, let's rename this guy to Stairs. And then let's go click Cube, hide you. We're going back to Stairs now, and we want to design a stair block. I wonder what direction. I'm just gonna take a peek over here real quick to see. Okay, so it looks like the X direction. Okay, so this is X. This is positive Y, positive Z, right? That's, yeah, negative. So it looks like in the original design, the stair was like kind of going this way, which it's important that we do that. So we'll have a loop cut there, and we will have a loop cut there. And then we basically just want to remove this chunk, right? So let's just go delete that guy, delete that guy. And this is what we're left with. And then what we can do is we can just control, 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 and then F for face. That's not quite what I want. Why did it select? Oh, I've got those guys selected too. Okay, let's switch to that mode. That F. That's better. Cool. And then we want to select these guys. Let's switch back to wireframe. Select those guys, F, and look at that. We got a stair block. I can do stair blocks apparently in Blender. Not as good as, well, I just can't do sandwiches. I think that's the whole point, but yeah. So I think this is what we want, right? Let's do Control S, save that tab to get back into object mode, and then we will hit export FBX, and we'll call this Stair. Because I guess, I don't know, stairs, there are 2 stairs there, so I guess we could call it stairs.fbx. Yeah, and was there anything we had to do here? I think this was it. Do we have to do that scale down to 0.01? We might. Let's just try this real quick, because I don't know if that was correct or not, but we'll see. So yeah, we got stairs.fbx there. Let's see if that worked. Hilbert Curve, I said hi, I think. Mary4F, how's it going? Finally managed to catch stream. That's good. Good to see you here. Eddie Dev, how's it going? And Lul Guy, good to see you here. I think you should add a Rickroll item. Impressive. Maybe. We'll see about that. I don't know. I broke something. Let's see. Am I still... Okay, yeah. So I'm still standing on ground. Were there errors here? Oh, failed to load block vertices. That's a big error. What's it say there? Error, YAML CPP, error at line 103, column 3, end of map not found. Line 103, column 3. Was I stupid? Did I do... Oh. Yep, that'll do it. You know, break stuff. Okay, I think that's it. Let's just remove this stuff. We don't need this. Okay. Let's get rid of that. Why are you still doing that? I think that's good now. Let's try it again. This is why I'm switching to JSON. I am switching to JSON too for anyone who's curious. So yeah. Eddie Dev, what happened to Cocoa Engine? I realized that it's probably not a good idea for me to be working on an engine if I don't have any really full games released. And I don't know, I just wanted to get more experience with like different techniques before I try and like abstract all that. It just felt a little weird. I was going backwards. Trying to start with an engine instead of a game just doesn't feel right. So I was like, I'm going to start with a game instead, and we'll go from there. But yeah, Hilbert Curve, white space moment, exactly. Thanks, Karkix. My brother designed that main menu screen. I think that's what you were talking about, the main menu screen. But yeah, he did design that, and I think it looks good too. Okay, looks like our stair blocks are gone. Why did they disappear? Did they load properly? Only 1 mesh per model supported, found 3. It did not export correctly. I gotta look at my errors, man. I just keep ignoring everything in the log, and it's like telling me all this stuff before I actually have to load the world. Okay, so we just want to do the selected objects. I believe this should be 0.01. That's what I was thinking, and it just didn't look right to me. I thought it would save that, you know, when I exited Blender since I saved the file, but I guess not, which is a little bit of a bummer, but. Okay, so we are getting 0.5, which is invalid. That's not invalid. Apparently, whoops. I did not mean to click that. Let's stop. That's what I wanted to do. Okay. That is not invalid, so I think we just have an error in our assertion, which does happen, correct? Let's see. We should be checking less than or equal to 0.5. Where is this? What did the error say? It said something about like 0.5. There we go. Yeah. It should be checking to see if it is less than or X offset is greater than 0.5. That looks correct. What was the, it looked like it said it was minus 0.5 and it said that was bad. Yeah, okay. Y offset is 0.5. Whoops, sorry. Y offset is 0.5, which is invalid. All offsets must be between minus 0.5 and 0.5. Which line is that coming from? That's coming from line 767. Did we do something weird here? No, yeah. I believe 0.500. You know what I think is happening? I think it's probably like floating point rounding error. Let's increase the precision on this to like 20. And I have a feeling we're going to see a digit way back there. And let's see. Yeah, looks like we're getting some digits way back there. So that's kind of bad. We can fix that though, and we will do that. Let me check chat real quick. Langors, I was asking if you're allowing high dynamic range. That's what it is. Thank you. I was like, I know HDR isn't high definition. It's like, it's something else. Colors, if you're going to use any tone mapping to convert HDR to LDR or something like that. I haven't looked, I've never done anything with color mapping and stuff, but I probably should, because I have noticed that the way it looks on my computer is not the same way that it looks on other devices. And I'm pretty sure that's exactly because of, well, no. High dynamic range is for colors like for when you have a really bright light that whites out a section of the image, right? And that's basically making sure you don't lose that information. I don't know. I might look into that at some point in the future. I just haven't played around with it at all, so I just wouldn't know, you know, what to do there or whatever. But it's a possibility. Little guy less than or equal to. So it's not the less than or equal to. Looks like it's just floating point precision errors. So what we can do is we can say, I have a function in CMath, near, or it's like close, compare. There we go. So if we can compare, we'll compare up to like 3 digits of precision. We'll say X offset minus 0.5F with, let's see, what is that epsilon? I'm just going to check what the default is. Okay, so the default epsilon here, which is basically just like how close of precision we want to compare, is min. That's probably not good. We don't want to, so that's like max precision. So instead what I'm going to do is an epsilon of like 0.1F. And what this should do is it should basically say, okay, give me this many decimals of precision. It might go down a bit. And so basically if it's close to 0.5 by this many decimal digits, then we're going to consider it to be negative 0.5. So what we'll do is we'll say X offset just equals minus 0.5, and we'll just clamp it. Else if CMath compare. It's annoying that we have to do this, but I guess it's just the easiest way since we have no control over the exporting, how they export it and stuff, and how Blender deals with that stuff. Let's also just go, we'll say, I don't know, epsilon equals, and then we'll just copy this. That way we're not using different values. Should I just be const? Oh, int. No, that's a float. Guys, it's in the morning. I am still waking up, clearly. That's definitely not an int. Okay, so what we can do is we can do this, and then we can say if that's true, X offset equals 0.5. Otherwise, we're going to do this. And you know, this feels very repetitive to me. I don't really, actually that's not bad. We'll do this 3 times. Okay, so let's copy this. I was gonna say we could make a function and stuff, but it's, you know, repeating this code 3 times doesn't worry me too much. So we'll deal with it. It's fine. Offset, maybe one day in the future. I could put it to do there, but it doesn't bother me. And lastly here, and we will say that, and this is Z offset. Okay, so if we do that, whoops, that was a bracket. Okay, So that should be good. Yeah. Now if we run this, we shouldn't get any errors because they're all close enough. Sweet. Didn't look like we got any errors. That's a different error. I should probably change that to a warning. To be honest, let's do that real quickly because this is not an error. It's just a warning. Line 166. Let's go there because it doesn't break anything. Okay, let's go to line 166. All the way up here. This is just a warning. Okay. And Langors, yes, that's what HDR is for. Yeah, I've wanted to experiment with it. Like another example of kind of color stuff that I want to experiment with is our light values. Instead, I had a few comments that were pretty good. The colored lights, they decrease just by decreasing RGB down by 1. But I think it'd be cool to experiment with, I think it's, what's the luminance? There's a color range that uses luminance instead of, colors. I can't remember what it's called. I think it's like Y something, CYMK or something like that. And basically decreasing the luminance, which shouldn't affect the hue of the color because the hue actually changes when the colors get far away. So it's just, there's a lot of cool stuff you can do with colors that I think would be interesting to experiment with. Okay, so looks like we got everything backwards. So let's go ahead and fix that. Should be easy. Let's go into Blender. If we just rotate Z 180 and export FBX, and that's our stairs 0.01 selected objects, export. I really don't like that I have to recheck those every time. It's not cool. YNVM, HSV, not hue saturation value because that's a little different. Might be YNVM, I'm not sure. sRGB, I'm not sure which one that one is too. That's just like a different kind of curve for RGB, I'm pretty sure. But I don't know. It's probably something, one of those. I don't know. Would you look at that? We got stairs. And they look correct. Those ones don't. Oh, because we need to fix we need to add corner stair block too. Yeah, so we got regular stairs there. Let's add a corner stairs, which are basically stairs. They're just a variant. If we go into this guy, you see we got stairs here, and then we've got corner stairs here. So let's remove vertices, remove indices. And then we also have inner corner stairs, which we'll have to do as well. So this will take in model, let's see, model file, corner stairs .fbx. And then we have inner corner stairs, which is just another version. Let's just make sure that's indented properly. Let's go into here. We will say Control C, Control V, escape, rename this corner stairs, hide this one, grab this guy, tab into edit mode. I believe what we want to do is, let me just double check. Okay, I believe I'm all flipped around. I have no idea. Okay, let's just try and remove this guy right here. I think that should do what we want it to do, but we shall see. So let's just do that. We will delete those vertices, and then we'll go ahead and let's just grab those two and those two. Nope, just grab those. F. That looks good, and we want to grab those guys, F. Okay, and I think that should be it for corner stairs. Tab, let's export, see if that works. So I'll say export FBX. What is this called? This is called corner stairs. That's all good, and we've got selected objects, 0.01. Okay, if I keep repeating that enough, maybe I'll remember next time. Who knows? We'll see. Let's try this. Let's see if that works out. That Max Play C# developer here. I wish we were capable of understanding C++. You can do it. It's actually pretty similar. Like, I came from Java, and my big problem was when I first started using C++, I would do stuff like vector equals new glm vec3. Because, you know, in Java and C# you use new all the time. Well, this does something very different in C++ because that creates a pointer and it heap allocates stuff. And so I had memory leaks everywhere. It was not good. Thank you, Patrick Luer. I think I said that right, hopefully. And Logic Bomb, thank you for following. And, oh wait, nope, that was a day ago. So Patrick Luer, thank you for following. I'm wondering why that isn't making any noise. Which is kind of weird. Usually it like makes noise, so. But yeah, so I think most people can understand it. It's pretty similar to Java and C# actually, but just some things that are different that like you got to be aware of. Oh, Langors, you meant NVM. Okay. sRGB is RGB, but gamma corrected. That's what I thought. It's just like a different curve or something. And the fit CMYK stands for cyan magenta. Yeah, that's for printers and stuff, I believe. HSL, hue, saturation, lightness. It might be that one, but I think there's like YMVK or something. Let's do this real quick. Luminance, color, range. Luminosity. Okay, maybe it's luminosity. Color luminosity. Is it this guy? Which one is it that I'm thinking of? I know there's one of them. Color ranges. Come on, somebody just give me all the different color things. I can't think of what it's called. Is it color ranges or something? YCBCBR? YCBCR? Color space. Oh, it's called color space too. That's what we're looking for. This is... Is this it? Also written as YCBCR. Okay, yeah, Y is the Luma component and CBCR the blue difference, red difference. Yes, okay, thank you. This is the one I was thinking of. So like the YC, I think, is for luminance or something like that. I think this is the one I was thinking of. So I appreciate it. Maybe it was something else. I don't know. There's some comments on the YouTube channel that should tell me. Yeah. How did I learn C++? Just by using it, or did you get any training? Yeah, I just I just used it and then broke a bunch of stuff and then realized that I broke a bunch of stuff and then kind of went about correcting my behavior. So one thing that did help me quite a bit was following along with this book. What's it called? Crafting Interpreters, which is an amazing book for free online. But his second half of the book goes through creating a interpreter in C. And C is, I think, the best way to learn C++ because it's a much stricter subset of the language, and it's a lot easier to learn the concepts by doing that. Yep. So that's kind of, I think that's what really transitioned me to actually understanding what I was doing. So YC, oh, capital Y, CB, CR. Okay, I got you. But yeah, let's see if I corrected the corner stairs. I did not. They're not there. Okay, let's see what we broke. We got an error. See, I gotta check my errors, man. Corner stairs.fbx not found. Well, that makes sense. Let's fix that. Corner stairs. That's better. Do you guys see like a yellow ring around the edge of the screen too? Because Streamlabs updated and broke some stuff, and I had to change some stuff. And now there's a yellow ring for me, but I don't think it's there for you guys. At least I hope it's not. So let's see. There we go. We got some corner stairs, and I got the corner in the right corner. So that's good. We also need to get inner corner stairs though, because if that's a stair. Yeah. Do that. Oh yeah, that is broken. Let's fix that too. And no yellow ring. Thank you. Okay, so it's just me. Let's go ahead. Let's hide. Whoops, I didn't want to do that. Let's hide. Let's unhide this guy. We'll say Control C, Control V. Actually, delete that. Undo whatever I did. There we go. Let's do a cube because it's going to be a little bit easier. starting from here again. Let me tell you guys, this is so much easier than what I was doing before by like manually mapping out vertices. Much easier to just design it in an actual tool for designing 3D stuff, but yeah, that's good. Okay, let's just hide, unhide. Let's see what's the orientation. Okay, so we need to go like that. So let's do that. Okay, so this is the corner we need to take out. Tab R, loop cut, control, or escape, escape. And then we need one more loop cut. There we go. And we just need to take out these guys, which I'll just do one at a time, I guess. Or actually, no, we just need to take that guy out. And then we need to go extrude Z 0.5. Does that work? That looks good. Okay. Grab this guy. Face. No, that didn't work. Is there a vertice there? I can't tell. Let me move. I wish I could move that thing. The stupid origin thing. That's just in the way. There we go. Cool. Yeah, there's a vertex there, I think, right? No, is there? I can't tell. I think that's just... Oh, no, there's a vertex there. Okay, wait. Control Z, Control Z. I need to go back because I messed something up. Okay, yeah, I definitely did that wrong. Okay. Extrude Z, go down, and I want to go down to here. How far is that? That is minus 0.5? No. Minus 5? 50? Okay, I'm in centimeters. That's why. Okay, so we got that. Let's do that as a face. Okay, cool. Let's do that as a face. That's good. And then we'll do this as a face. Okay, there we go. And I believe that is our corner stair done. Looks good to me. Let's export it. Make sure it looks right in the game. Export. Come on. Export. Oh my gosh. I can't do this today. FBX. There we go. Inner corner stairs. Inner corner stairs. FBX. And we go export. Let's go into here. I didn't check my stuff, but I think we should be good. Let's go into here is what I meant. Inner corner stairs. Let's delete the vertices and the indices. We no longer need those. Delete that stuff, and we say model file, inner corner stairs. This is so nice. Usually on stream, I'm like struggling through trying to fix stuff. But for once, we're just like using something that actually worked on the last stream, and it's just all working out, which is really nice. Lol guy, why do you hide your mouse pointer? So if I turn it on, for some reason, whenever I'm hovering over text, the way the cursor shows up on stream is like it disappears. And it just because the colors, like they blend into each other, and so the compression and everything just makes it disappear, which is super annoying. So I decided I'm just gonna like get this yellow thing, which is just some add-on using hotkey or something like that. Auto hotkey, I think, and then it fixes a lot of stuff. So it's just easier to do it that way. But yeah, we still need to fix that ambient occlusion. Logic Bomb, how's it going? Or is it Logic Album? Logic Album. I think that's what it is. Okay, so I think this is all good. What is this guy? This is broken too. Let's just go through systematically fix the rest of our broken models. We've got, next up, vegetation. So vegetation's pretty easy too. We can just go ahead and let's just duplicate our cube once again. We'll get rid of that. Show that. Control C, Control V. This will be vegetation. And we'll hide that guy. Okay, so vegetation is literally just two planes. So if we just do that, and then if we get rid of this guy, this guy, this guy, and actually we can do something that I've been wanting to do but haven't done because it would have been annoying. We can rotate this, which will be cool. So we'll do that afterwards. Delete and delete. That might break stuff though, so maybe not. I don't know. We also don't need this or this. Okay, so what we'll do is we will grab that guy, make that a face, grab that guy, make that a face, and that is our vegetation. Let's go ahead, Control S. Hopefully this works out good. I think it should. It might end up weird because we technically need two faces here. We'll see what happens. Okay, let's export that. This is going to be vegetation export, and we will go into here. Yeah, because you'll notice I have 4 faces. I don't know how. We'll see what happens. Model file, vegetation.fbx. Okay, let's go ahead, import that, and see what we get. No errors. That's good. Logic album. I'm doing great, except I have to refactor my whole Minecraft clone because I only used HPP files and no CPP files. Yeah. It's logical bomb. Oh, okay, there we go. Bomb is German for tree, and I'm probably saying that wrong. Baum or bomb? I don't know. But it's okay. I've done similar things before. Lol guy, I think you should make the flowers have custom models just to be different. Well, so the thing with the vegetation is you can actually make the textures shorter or higher, and so it all still kind of works out. Let's see, because I've got flower here. Oh, sweet. That, oh no, yep, see, it's broken. It only works from one angle, so we'll have to figure something out for that, like double-sided faces or whatever. So you'll see that the flowers, though, are actually shorter, even though it's the same model. And the reason it's shorter is because these guys just have a taller texture. Sorry, I'm trying to think through how we want to do double-sided faces. I mean, it should be easy. We probably just need to separate those guys into their own kind of rendering pass type thing where we don't do back face culling. Just create faces on both sides of the model in Blender. Does that work? Disable backface culling? Yeah, we could disable backface culling, but that would require like a whole different render pass. And ideally, it would be easy just to create 2 faces in Blender. But can we do 2 faces? Does that work? Or would we have to like extrude that and like rotate Z 180? Maybe that'll work. Let's try this. Extrude, move it 0, rotate Z 180. I think that's right. Z. Oh wait, no, Z is not what I wanted to use. Clearly. But it is. RZ. I don't know. That's looking funky. I'm not sure if that's going to work the way I think it will. But yeah. Mary4F, if you want culling for some blocks, you can discard pixels in the fragment shader if they are not front facing. Yeah, but I think that's when you mess with the pipeline like that, I think that can incur unintended overhead, because if you just tell OpenGL to disable backface culling, I think it can discard it earlier in the pipeline than if you do it manually yourself by discarding pixels. So I don't want to do that. I think a separate render kind of batch call would be better for something like that. We can add that later, though. That is not necessary. And what we'll do is we will have something like that, so that we can just turn it off for this guy. For now, it's not going to do anything, but eventually we'll get there. Okay, the vertical half slab. That is pretty simple. We will just say model file, vertical half slab. Carpet, I don't actually have yet. Path block, don't actually have yet. Fence block, don't think I actually have that yet either. Or half fence. I think we tried to add those, but they failed. So let's just add the vertical half slab and then we can move on. And we'll get the next portion up and working. So let's go ahead, hide that, cube, unhide. we're doing vertical half slab, so we can go ahead and call this half slab and tab, loop cut, there, delete, there. Let's see, do that. Face. There we go. That's a vertical half slab. And let's go ahead and export. FBX. Call this vertical half slab. Export. And that's good. Let's see if that's fixed. And I think that should be the bulk of it, and then we can kind of move on with our lives for now. Okay. I gotta finish this coffee. It's getting cold. And cold coffee is horrible. Okay. I think that's good. Cool. So we've got vertical half slab. That looks good to me. Sweet. Let's just make sure I oriented it correctly. I think this is it. I did not, because this should be going that direction. If we go this way, yeah, it's going over here. I don't know. Does that make sense? Should we have it go that way? So basically you click and then... Does that make sense? Yeah, maybe that does make sense. It doesn't matter too much. There is no vertical half slab in Minecraft, so we get to define what happens. These should be the other way, though. I think that's what I intended was for this. Or no. These, okay, those were cubes. Wait, let's fix this. So that should be cube. These guys I did as vertical half slabs, just to experiment and see what's possible. You know, we're pushing the boundaries of what's possible in Minecraft here, right? Okay. And see, look, you get like some extra, we need to fix ambient occlusion, but you get some cool stuff, right? Okay, cool details that aren't available in the game. I guess you could use trapdoors, but it's not the same. It's not the same. Okay, we need to fix that stuff. Hilbert curve, I agree. Cold coffee is really bad. I like the pun, Hilbert curve. And yes, cold coffee is very bad. Fortunately, it's gone now. I have not gotten any sleep the past couple nights, guys. So that is why I'm like living on coffee right now. And it makes me a much more productive programmer. But I don't like being dependent on coffee. So it's like a catch-22, you know? I don't know. Okay, so it is terrible. I agree. How do we fix this stuff? Let's try and analyze what's happening. Okay, I'm guilty of this, but when you're trying to fix bugs, you should never just like go in and start blindly changing stuff and hoping it fixes it, which is what I usually do. The best thing is you should try to understand why it's happening. And I have a feeling I know why this is happening. So let's go into the code, confirm my assumptions. Once we confirm my assumptions, we can go and fix it and we'll be good. These are our broken fence blocks. We can just get rid of those for now. Charlie Pie, our vertical slabs look cursed, but I'm enjoying it. That's good to hear. Little guy, why do you use 32 by 32 textures? Because I think that's what Minecraft uses, 32 by 32. I'm using Old Faithful texture pack here, and then my brothers have like designed these oak log textures. No, not these oak log textures. These aren't oak logs. If we add oak logs, they've designed those. Yeah, over there. And some other stuff. But I think Minecraft uses 32 by 32. Not trying to rely on coffee. It is a good habit to get into. Not to rely on it, that is. Okay, so what's wrong? Why are we getting these weird ambient occlusion problems? Let's explore this a little bit more, first of all. So let's get a sand block, okay? Let's put this guy up here. Kind of get our test bed. Actually, let's go switch into creative real quick. And then let's go out to here. Do this. This. Okay, we just want to get like a little thing so that we can sort of test stuff. Okay, so let's put a block here. What happens? We've got ambient occlusion over here for some reason, over here for some reason. Okay, wait, do you see? This does look correct. That's what I'm thinking. Just tilt your head kind of like that, And what you'll notice is this looks like the bottom, or what should be the bottom of the cube. This looks like what should be on the ground here. And this looks like it's fading properly up that way. This is broken just because of that, but this also looks like it should be fading up that way. And so what I'm thinking is happening here is I think that our model rotations are messing with how the ambient occlusion gets calculated. And so we just got to confirm that. And once we confirm that, we can fix the rotations and everything should be good. So let's go and confirm that assumption. Minecraft has 16 by 16, does it? Huh. I guess Old Faithful just uses 32 by 32. Yeah, I didn't know that. I will have to inform my brothers because they were getting annoyed at having to do 32 by 32 textures. So they'll be happy to hear that. Essie Woods, what's good? How's it going? I hope you're doing all right as well. So let's go block map. Yeah, I didn't mean, I think that came off worse than I meant for it to sound. I meant to say, like, I hope you're doing all right because you said what is good, but don't know if that came off the right way. Let's go into chunk.cpp because I think this is where it's happening. I'm like thinking about how I'm trying to solve this problem. So when I start thinking about how I'm trying to solve stuff, I'm not thinking about what I'm saying. And then that's not good when you're talking. Okay. So inside of generate subchunk render data, what we want to do is look down here because this is where we're all good. Okay, that's good. Down here. Okay, right here. So when we go through, we loop through all the faces. We check if the surrounding block is covering this face. If it is, then don't generate render data for the vertices. Otherwise, add all the vertices, texture ID, side texture, top, bottom, all that stuff. And then how do we calculate the ambient occlusion? This is how we calculate. Okay, so this is where we calculate the ambient occlusion right here. And what are we using? So we're using the Vertex Offset. Okay. So we got to kind of reverse engineer this. It's been a while since I've looked at this. So we got to kind of get back into whatever headspace I was in when I actually made this. Okay. So we got Vertex Offset, which is the vertex offset from the center of the block. We have the block center position, and then we have the index of whatever this vertex offset is. First, we check if the block is occluding this face, because if it is, we don't need to calculate ambient occlusion for this face. So then I skip it. We've got this face component to 0. What is that thing? Okay. Yeah, this was a complicated algorithm when I made it, and it is still complicated now. So we say vertex offset is the rotation times the vertex offset minus 0.5 plus 0.5. So I'm just applying the rotation here. Okay, so I apply the rotation and then I get the sine direction from the center of the block to this vertex. Yeah, this is complicated. Reverse engineering your own code because you were too lazy to comment it. Yeah, pretty much. And even if I did comment it, though, unfortunately, this is like... I remember what I was doing, and I barely understood it when I was doing it, so it wouldn't have been good comments. Okay. I think I can see what I'm doing. So... when we're looking at the left face, right? Let's get rid of this. Cube X. Okay. So left face would be like, let's say this is the left face, right? Right here. Let's go select faces. How do I do that? Face select. There we go. So let's say we're looking at the left face. Then basically we want to zero the Z component. If we're looking at the left face, what's happening is we actually only want to check the blocks over here for ambient occlusion. And what's going to happen is, like, if it's this top corner, then what we want to do is we want to check these 4 blocks, right? So if we're checking that corner, and the reason I have to figure out which face it is because if we're checking this corner and we're checking this face, then we actually have to check the 4 blocks up above it. But if we're checking this corner and we're checking this face, we want to be checking these 4 blocks. So this is basically what I'm doing, is sort of setting that up. So when we go back to the code, that's what these arrays are just helping us out with. They're basically saying if we're looking at the left face or the right face, we don't care about the Z component because we're looking at those faces. If we're looking at the top face or the bottom, we don't care about the Y component. And if we're looking at the front or the back, we don't care about the X component because those are the ones. And then this is the reverse of that. If we're looking at the left face, we only want to use the X and Y components. Same with right, top and bottom, we only want to look at X and Z components, and front and back, only Y and Z components. So that's what's happening here. Isn't AO just darkening a vertex if it's shared by multiple blocks? Sort of. I've got to do some interpolation and stuff, which is why I have all this complicated stuff. But yeah. So then we get the vertex offset index. We get the block center, we get the vertex offset, and then we rotate that. Then we get the sign directions. Okay, so then what we do is we zero out the component we don't care about for that sign direction, so we're not looking in that direction. Now we have a vector that points kind of like, if we're looking at this face, the vector points this way, which is good. And so then what I do is I say the signed direction side equals sign direction. Face components, rotated face, 0 equals 0. Oh, okay, so then I'm getting like I'm getting the tangent vectors is what I'm doing here. So if we go back into here, what I've basically got is I've got the vector pointing this way in the y-axis. And what I want is I want a vector pointing to the left if we're looking at this vertex. And I want a vector pointing up. And so that's what I'm doing now is I'm getting the first side, which would be like one of the left vector. So let's call this something different. Tangent vector. Tangent vector. Let's call it that because that makes a little bit more sense. Or what? And that should be equals sign direction, not that. Okay. And then this one will be our normal vector, right? So we're getting basically the forward, tangent, and normal. Or I guess perpendicular would probably be better. So then we can do that, and we can do that. So now we have our normal, our perpendicular, and our tangent. And then what we do is we go add, this one was the tangent, this one was the perpendicular. Okay. So then what we say is we say the corner block is whichever block is at the block center plus our normal direction plus our signed direction. We say the side block is, oh, the face normal. Okay, plus the signed direction, which would be, at this point, the signed direction is just our forward vector. Let's call it that. We want to be explicit here. Make it a little bit easier to read in the future. Okay, so we got forward, tangent, and perpendicular. So the corner block is the center plus the normal plus the forward. Is that correct? Wait a second. No, that is not correct. Sign direction does make more sense here. Okay. Because this isn't actually, this is getting the corner block. So what is happening here is this is actually getting, if that's the corner, it's getting the block up here, right? It's going at an angle. So it's going center to here to here. So that's what's happening there. So that does make sense. The side block is the block center plus the face normal plus the tangent. So that would get the block over here. The other side block is the center, face plus perpendicular. So that's getting center plus the face normal, which is over here, plus perpendicular, which is here. Oh, wait, okay, this is the side block. This is a side block, and then we're going to get the block directly in front of us, which is top block, which is the block center plus the normal. Okay, we should call this forward. block. This is going to be our perpendicular block, and this is going to be our tangent block, and that's the corner block. Okay, I guess we should call these pose because we use them down there. Okay, so we do that. This one I believe was tangent. This one was perpendicular. And this one was forward. Okay, and then let's go ahead. Let's just change these two. So corner is corner, other side is perpendicular block. Let's fix that. And then side is tangent block. Okay, fix that. Okay, and then what do we do here? Side was tangent. This was perpendicular. Okay, and then we also need to fix that. This is just calculating, like interpolating light colors and stuff afterwards. Okay, and then corner block should be fine, and forward block is what this one is. AOY block is forward block. Just make sure that's right now. Okay, and I think that should be good. Cool. So now this is a little bit easier to reason about. So is this GTA 6? Nope, Half-Life 3. I wish. No, just Minecraft clone. We're trying to fix some bugs right now, though. Hopefully. Okay, so we've got the corner, we've got the tangent, we've got the perpendicular, and we've got the forward. This is a little bit easier to reason about now. I think what's going wrong is we're probably breaking something when we do these rotations. How are we getting these rotations? This rotation's coming from where? It's coming from rotations. And where are we getting that thing, though? What is that rotation? Okay, that's getting the rotated face map for this rotation. Where is this rotation coming from? Okay. This is coming from here. Block.getRotation. What is a block's default rotation? A block's default rotation, I believe, is 0, 0, 0. Okay. That's good. So in the case of our cubes, we shouldn't have any rotation applied. So when we do this, so in the case of the cubes, I guess, this shouldn't even do anything. So if I comment this out, we should still get the bug. Let's just make sure that's correct. Minecraft 2, I wish. Actually, no, let's keep away from Minecraft 2, because usually the second game is always the worst. It's like the first and the third are usually good, but the second's always bad. In my experience at least, I don't know. Okay, well that's good. It is still broken, so we are understanding some of this correctly. Because we still have this bug, so that's good. So rotation does nothing for cubes. So the rotation is hopefully not broken. What is broken then? The sign direction, let's see. Do I still have this code? I had code that basically drew the blocks so that I could debug this type of stuff. Do I still have that? I don't think so. Did I commit it to GitHub? I hope so. Let's check GitHub real quick. And hopefully I saved this at some point to GitHub so that I can look at it and figure out what I did. Okay, let's look through our commits. Okay, so that's block rules. Fix the faces that were not actually... Okay, fix lighting for rotated blocks. Okay, I believe if anything, it's probably going to be somewhere in here. Get log rotations, get fence... Yeah, I believe it would probably have been like in here, so maybe here. Let's go into Minecraft, source, gameplay, player controller, and let's see if I hopefully committed that code, because it would be great to have it now. Would you look at that? I've got it. Okay, I think so. Block looking at air block. No, okay. Wait. Rotation type, new block. Dang it. Okay, I thought that was it. I don't think it is. And let's just triple check in here. I don't think it is in here. Place block, get or place block, I think is what I called that. Get or place block. Check, place, or break block. That's what I called it. Let's go check. Don't think I have that debug code commented out in here. No, I do not, which is unfortunate because that would be helpful. Okay, let's rewrite the debug code so that we can debug this. So basically what I want to do is I want to take all this stuff and draw these block positions and make sure they're correct for the place I'm looking at. So let's grab all that. Let's grab this, put it in here. We don't want to do this. Let's just do, okay, if res.hit, this is where we want to add stuff. And we'll add some more drawing stuff. And then we will commit this so that we won't have it lost. And I'll make the commit name super explicit what this is. Okay, so let's do this. So the Vertex Offset, what are we going to call that? We could actually just, instead of using Vertex Offset, we could use the raycast hit point, which I believe is that point. Yeah, so that's what we'll use. And it should do the same thing. And we need this face to 0 stuff. Okay, so we need these things to get this to work properly. So let's do that as well. Okay, so we got that. We need rotated face, which in this case is just 0. We know that, so we can just sort of substitute that. Doesn't matter too much. 0. Okay. Block center, which is our block looking at pose. Okay, so that, no, that's not it. Oh, it's this, res.blockCenter. That's what we need. Okay, so let's substitute that. Block center, and then face normal, which is our res or raycast hit normal. Should give us the same thing here. So let's do that. Okay, and then we want to draw these blocks. So this is not get internal block. Instead, what this is world get block. Get world block. Come on, it's something like this, right? What do we call it? Let me check world.h. I thought I had something in here. Maybe I don't. Maybe it's in chunk. Yeah, I think it's actually in chunk manager. Chunk manager get block. There we go. Okay. So we call it that. What is this expecting? It's expecting a GLM vec3. Cool. So we can just pass that stuff, which is even better. Cool. Okay, we'll do the same thing here. Do the same thing here. And same thing here. Gotta love it, right? Debugging. Great stuff. I mean, at least I have the debug tools here so that we can actually go through and do this stuff. Okay, so then what we want to do is we want to do the same thing here. And what we want to do is we will grab that, 4 of those, and instead of that, we want to do our tangent block, which would be, I guess, our tangent block position. We don't even really care about that stuff, right? Yes. So our tangent block position should give us the center. Oh, so that should be tangent block pose. This would be our corner block. We also want our perpendicular. And we want our forward. Okay, so those, we can get rid of these. We don't actually need that stuff. Okay, so then we just want to draw where those are, and let's give it a bright red color so that we can actually see what's going on. We will say glm vec4 1001, and that should give us, let's just copy all that. Color we want. Okay, so now we should have some debug stuff. Let's see if this works now. Would this be possible in C#? Yeah, this could be possible in C#. I mean, it's Minecraft is written in Java, so I don't see why you couldn't do it in C#. Okay, so what we should see is hopefully the correct blocks popping up. So we're getting a bunch of blocks here, and things are kind of messed up just because of my debug lines are broken. Okay, so this is our problem. We can... Is it a problem? Wait a second. It might just be because of the way I'm calculating stuff. Possibly. What it should be doing is it should be drawing like the blocks for this corner, which would not be over there. I don't think I'm drawing the correct stuff though. Let's see. Just make sure. Double check. Nice job. Chunks working is a good first step. Okay, so we want to... Sign direction is the res.point. Is that correct? Res.point. Oh, I'm doing minus 0.5. We should not do that. Okay, let's see if that fixes stuff. I don't... Maybe? I don't know. We'll see. Okay, blocks. Or blah, I guess is what that's called. Creative. Let's see. If we go... That does not change stuff. Okay, let's draw our point too, because I am wondering if that's even the correct point. Render draw box at res.point, a 0.1f stroke width, which I guess we'll do the same as the block highlight stroke width. And color we'll do as green. Okay, let's do that. Just make sure that's at least correct. I believe there's a Minecraft client called Alex that's in C#, so it is possible. Yep. It definitely should be possible. I mean, if Minecraft is in Java, C#, I don't know if it's faster or not. I have no idea. I've never done performance comparisons and stuff, but... Okay, so that's definitely correct. You can see the green box is following my cursor, which is what it should be doing. Like, that's just telling us where our raycast is hitting. Okay, so that's definitely correct. We're just getting the wrong cubes. Why are we getting the wrong cubes? We've got sign direction equals the point. Oh, minus the center. Yeah, that was right. Except we don't want to do minus the center. We want to do minus the block center. Okay, so what's the block center? Res.block center. That's what we want to do. Okay, let's try that. We're getting there. Java is faster for some reason. I don't think you can... It's hard to say that about any language. I would be wary of saying that, just because like you can tweak code and make it better or worse and do all sorts of things. Okay, so this is a little bit better. You can see that now when I go up and down, these blocks change, which is what should be happening. But we're still getting the wrong blocks. So let's see. So we've got the sign direction, then we zero out component, we get tangent vector, we zero out component, we get the perpendicular vector, we zero out the component. Then we get the corner block, which we say is the res block center, hit normal. Let's draw the tangents. So we'll say render draw line start is going to be, we'll do our res.hit. End is res.hit plus, we'll do res.hit normal. And we'll do block highlight stroke width. This will be blue. Okay, so we'll draw that guy. Why doesn't it like this? Res, what's it saying? Draw a line that takes a vec3 res. What's it saying? To bool. Why are you trying to convert to bool? Is Visual Studio just being slow and broken? Res.hit. Okay, that's good. Oh, hit point. Or I guess point. Okay. Visual Studio is not being stupid. I was. Okay, so we got that. So that's plus the hit normal. That's the forward block position. Okay, and then we want res plus hit normal plus sine direction. That will be another one. So we will do that here. And this should be vec4. What color? We'll do 11GB. I don't know what color that is. We'll see. Okay, and then we want one more, which is the tangent block, which we're going to do res.hit normal plus tangent vector. Okay. So that plus tangent. Oh, that shouldn't be sine direction. That should be perpendicular is what we wanted there. Okay. And then 0, 1. So let's make sure those are correct. You know, we're just checking everything. Writing fast code in Java will be faster than slow code in C# and vice versa. Exactly, yeah. It all depends on what you're doing other than lack of proper SIMD in these languages. It's hard to measure true performance in JIT compiled languages because the on-the-fly optimizations that might happen. That is also true. Yeah. Very true. Exitnal. I agree 100%. It's just too hard to compare. You can't compare languages. Unless you're comparing C++ with other stuff, in which case you can compare standard library algorithms and stuff, and it's usually immediately clear what stuff is right. Okay. First of all, those are going out to like infinity for some reason, which is not cool. So I must have messed something up there. Unless these hit normals are broken. And that's why they're going out to infinity. Is that what's going on? So we say the point plus the hit normal plus, then the point plus the hit normal plus the perpendicular vector. Let's comment out these two guys. Let's do this one by one. So is the hit normal correct? I assume that's correct, because if that's not correct, then my raycasts are broken, but they all look like it's working fine. So I'm going to say that that is correct, but we'll double check. Yeah, that looked correct to me. Okay, yeah. So you can see that this goes up or down. Let's make it a little bit smaller, because I think that's probably why it looked like it was going out to infinity. It's kind of big. We don't need it to be that big. We can do hit normal times 0.2. So that should be like 20% of a block. Okay, so that looked correct. Let's do the same thing here. We'll do times 0.2f times 0.2f. Let's make sure that guy's working right. That is our hit normal. So this is our perpendicular vector, which I might be doing that wrong. I think I just want to do the perpendicular vector, but let's see. Okay, we're getting a cyan color, and that is pointing in the same direction. Kind of. Okay, yeah, so you can see that okay, yeah, so this is actually pointing correctly, because it's not the tangent, it's actually pointing like to the corner, and you can see that it's going based on our normal direction plus the face that we're going, which is correct, if that makes sense. So that looks good. But what I want to do is I don't actually want that. Let's just remove the hit normal, so that we just get the perpendicular vector, because I just want to make sure those are correct. And then we can go from there. To see if the blocks we're getting are correct. Okay, yeah. And that was looking pretty good to me. Cool. So yeah, you can see that this is looking good. It goes to the left there, it goes to the right there, depending on which direction. So that's left, that's right. Cool. Why am I standing on top of these blocks? Is that right? Oh no, that's right. Okay, I was so confused. I was like, why am I not going down to the ground? But no, this is right. Let's just real quickly, let's do that and that. Okay, so that we can get a little bit closer. Cool. Okay, last vector we need to check, which should point in the final direction. Let's make sure that's working correctly. Is this guy. We want to do not plus the hit normal, but just the tangent vector times 0.2f. Let's see if that's working. If it is, then we move on to the next portion, which is getting the correct blocks drawn. Okay. Cool. So that is wrong. I can see that immediately. Is it? Wait, no. So that's, yep, those are all the 3 correct vectors. Those correct. But what happens when we look here? Where's that purple vector? It's disappeared. Wait, has it? Yeah, it's disappeared. It's not there. Where is it? Now our blue vector's disappeared. Okay, I think this is our problem. It seems like we're losing one of our vectors. So it looks like I'm zeroing out too much or something. So this tangent vector, what's going on here? We say tangent vector equals the signed direction. Then we do face components 0, 0 equals 0. Huh. We'll have to check 0, 0, 0, 1. That is strange. Take a look at that in a minute. I'm going to take a break real quick, guys. I will be back in like 5 minutes, and then we will continue where we are now. So hopefully you guys are enjoying this. If not, I don't know. Let me know. But yeah, let's go ahead and do that. And also, I just noticed Robert Sam, thank you for following. Good to see you. But yeah, taking a break real quick, and I'll be right back. Man, I should have called this stream fixing ambient occlusion because I feel like that's all we've been doing. But let's see what's happening here. So, and by the way, I'm back. So probably should announce that before I just start jumping back in. Okay, so we're zeroing out both components for some reason, which isn't good. Let's just draw our signed direction as well, just to make sure that that is correct. That should be like a diagonal pointing kind of the way that our point is pointing. So we'll do this times or plus the signed direction. And let's just make sure that's correct. That will be a white line, and let's go ahead and draw that, see if it's correct. And the basic idea is that the signed direction component will have all the appropriate information, yeah, so that we can get exactly what this is. This doesn't look right though. Okay, so that's a problem. The sign direction is pointing in one direction. It looks like we're modifying that. Are we modifying the sign direction somehow? We are. That's not good. We should be doing that last. I wonder how long this has been broken. Tar83, thank you for following. Let me fix this too, because this is... No, that's fine. That's in the wrong place. Okay, so if anyone else follows, it should show up in the middle, not behind everything. Okay, so I wonder how long this has been broken. This was wrong. We should be zeroing this out last, because if we don't, we lose some information. I believe. Let's try this. Let's see what happens. Okay. So we do that. And now that should be pointing in a diagonal in the direction that that point is from the block. It still is not. Is it? No, it's not. The white vector should be like changing. It should be pointing towards our point, and it's not. Why is it not doing that? So we say sign direction is the point minus the center. And we're taking the sign, which should just convert that to like ones or zeros depending on that stuff. Advanced Coder for Life, thank you for following. And now it's fixed, so that's good. And I'm hearing the sound now too, which is also good. But yeah. Is it because we're doing this sign direction face component to 0 equals 0 thing? I mean, I guess that would make sense. Actually, yeah, let's change the name of this. Let's add one more vector here. So glm vec3, because this clearly isn't the sign direction. This is like the sign direction we care about. What do I even call that? Normal? I think. Wait, okay. Hit normal plus the sign direction. I've really got to think about this. Okay, wait a second. Let's just call this something else first. Vec3 temp equals signed direction. Okay, let's just do that real quick. Temp, let's make sure temp is correct, and then we will go from there. So temp instead of that. Okay, let's do that. See if that's okay. Have I tried GitHub Copilot? I have not. I don't see myself ever really using it either. Not because it's like... I don't know. I don't like code auto-completing. I like to know what I'm writing and stuff. So I think that's the reason I don't see myself using it very much. Okay, so if we look at that sign direction, why is it flipping like that? Because what should be happening is this should simply be the point minus the block center, which means it should be turning the whole time. Not kind of doing that weird. Oh, wait, but it's the sign. Okay, okay, no, this is correct. So look, it's like pointing in the direction of the vertex of the quadrant that we're looking on. So it kind of bounces up and around. And then if we were to look up here, yep, points in that vertex direction. Cool. Okay, so that is correct. And now look at that. We're getting all the correct normals there. Are we getting the correct blocks? No, we're not. We're still getting something wrong. Okay, so the sign direction is like pointing that way. It's good. Now, let's double check what we're doing here. So we've got signed direction. Then we say signed direction face component to 0 equals 0. So what are we doing here? We're saying if we're on the left face, 0 out the Z component. Which, let's draw that in yellow. Okay, we're drawing everything here. Let's do this. And this will be RG, which should be yellow, hopefully. Sam check. From what I see, it's just moved by 0.5 on all axes. Well, it's still kind of broken because when I switch to the top face, it's not switching to the correct blocks. Like one of the components is getting completely zeroed out for some reason. Yeah, because if I go up to the top, it's still going like up, which is wrong. It should be going like flat. So, okay, so this signed direction is basically pointing up into the left here, and then up here, it's still pointing up into the left, which is wrong. When we hit the top face, should we be zeroing out? Huh. It looks like it's doing the same thing for all these faces. It's not changing per face. Let's look at this code one more time. So, we get the sign direction, face to component 0. So if we're looking at the left face, we zero out the Z component, which means it should be pointing down. Oh, is it because of, wait a second, because of, we're not adding the face here. What's this look like here? Oh, I'm an idiot. I just said that was okay to be 0. It's not okay. We're doing different stuff now. Yeah, it's SPWT77. Thank you for following. Good to see you. Okay, so I was stupid. This should not be 0. This should be the face that we're hitting. So res.face or like normal, converted to a face, which we'll have to fix. So let's just grab that. Okay. So we might actually be good here. I don't know. Okay, so we're just getting the face by doing that. Let's see, we're getting cube face. Let's do some sort of cube face to whatever. Yeah, and when you fix this, I think the only problem will be the 0.5. I think you're right, but it's good to just double check. And before it was different. Okay, we'll just double check real quickly though. Let's do static cube face, normal to face, normal. Okay, and then we'll say switch. We can't do that. We'll say if normal dot x is greater than 0.5 and normal dot y is greater than 0.5. Is this right? No, we should only be, okay, never mind. That's gonna be positive x, return cube face. What is positive x? I think that's front in my code. Else if back, okay, else if that right, no, that's top. Nope, y is less than 0.5. We want to return bottom. Else if that, return right, otherwise return left. Okay. So normal to face, cube face, face equals hit.normal or res.normal. Okay, there we go. Now we can use that. And we can just cast that to an int. Should be fine, because that is the intended behavior. Okay, so if we do that, I think Sam's right. I think we're going to get the right things now. Just offset by 0.5. So let's see. Okay. Yep. Looks like we are getting... we're still missing a vector here. We're missing a vector here. We have all the vectors here. So that's still not good. Let's see if it's giving us the correct blocks. So that's the wrong blocks. Is it? No, I think they are just shifted by 0.5. Yeah. Okay, let's fix that real quickly. So the reason they're shifted by 0.5 is just because of the way draw box works. I think it draws it from, no, it draws it from the center. Tangent block pose, what is that? Center plus hit normal plus tangent vector. Let's just add a plus that. I don't know. And see if that fixes it, because it's just offset. Doing the exact thing I said never to do before, which was just changing stuff and hoping it works. That's funny. Okay, let's see if this fixes it though. Let's go back into here. Okay, we are offset a little too much. I think we should be doing minus 0.5 or something. Trying to see. I think let's understand what's happening here real quick. Okay, so we do block center, which should be the center of the block, plus the hit normal, which should get us 1 unit in that direction. And the sign direction should also be 1 unit in the proper direction, which is weird that it's not right. The block center is already wrong. Add the 0.5 on the block center. Yeah, I know. And that's the block center should be the block center is what I would think. Because if we look at the block center, I think that is correct. Because look, if we look at block center, we're drawing a box at the block center. And if we look at that, there should be a gray box around the block, which is correct. So I think that's fine. Let's double check it real quick though. Yeah, you can see there's a black box around the block center, which is fine. So the block center is fine. It's just the normal directions, which are not fine. Since the models are built, I know, but I'm using the block. I'm drawing the block center right here. So I'm using this to draw the block center. And that is drawing in the correct location, so that should be fine. So if I add normals to that, which is what I'm doing here, I'm just adding normals to that. If they are a unit direction, which means they're just like length 1, then it shouldn't get offset by 0.5. So I think there's something wrong here. Like, oh, it's because of this floor, I think. Why am I doing GLM floor? Why was that there? I have no idea why that was there. I found a bug in my chunk renderer code and I fixed it. Nice. It's always good when the bugs get fixed and not get added. Not sure why I had that floor there, but that definitely I think is what was... Okay. Yeah, these are definitely still not correct. Let's add those back. Okay. And then let's add 0.5 from here. Why doesn't it like that? Plus. Oh, wait, I'm drawing, why am I drawing, why are these IVEC 3s? Now I'm just getting confused because of all this stuff. Let's go back into here. What's happening here? Yeah, okay, so I think... Let's change this to not an IVEC 3. Let's remove these floors again. I think the reason I did that was just so I get the correct location there or whatever, but we don't need it in this case. Okay, let's try that. I think that should be fine, hopefully. Okay, let's see if we got it now. And this is all just to draw the blocks. Okay, there we go. Now we're getting the correct locations. Except they are still off. And I think this is what's wrong, is like... So that's the correct blocks for that one. And we need to go somewhere else, because this stupid water rendering bug is really annoying. Okay, here we go. So if we look up here, we've got those blocks, but we're going up. These are the correct 4 blocks for this corner. That's the correct 4 blocks for that corner. That is not the correct 4 blocks, and neither is that. So what's going on there? And I think this is where our bug is coming from. And we can verify that this is where our bug is coming from. So apparently this is getting affected by this block, so if we change that, does it change the ambient occlusion? No, it does not. What if we do that and that? And that? No, it's not changing the ambient occlusion at all. But if we do that, it does change it. And that does change it. Yeah. So do I just have another bug in the rendering code? And we are just getting the wrong positions here. So block center plus hit normal plus direction. I think that's right. What we can do too is we can remove this. We know that's fine. Let's check our tangent and normals, because I think, yeah, we need to check our tangents and normals, make sure those are correct. Now you guys get to see the pain that I go through off stream when I'm trying to debug this stuff and just like going and restarting and trying again. What I need to do is I need to come up with some way that we can have like a, you know, kind of a test world thing where basically I don't have to restart the whole game and I can just load up like a subset of textures and stuff so I can quickly launch the game and iterate and stuff. That's something I want to do eventually. Okay, so look, the normals are all correct here, which is why we're getting the correct blocks here. And you'll notice the purple normal flips. I guess that's the perpendicular or whatever. It flips, which is correct. And if we go down here, the blue flips, the cyan, I guess, flips, which is good. So we're getting all the correct blocks there. When we go up to here, we lose a vector. We're only getting blue and purple here. We don't have our cyan vector, which is bad. So we lose that vector, and that means we lose one of our directions, which is why we're getting the wrong blocks now. So why are we losing cyan? And what is cyan? Which one is that? We got blue, purple, cyan. So blue is that guy. Purple is G and B is cyan. So this is cyan. Perpendicular. So why is perpendicular losing that component? Is cyan not going into the block? Oh, that's a good idea. We should check that. Thank you. The End Hunter. Thank you. Let's check and see. Because it could be. I don't think it is, but let's see. Of course I can't do that. Okay, well, I can't query apparently because I'm not actually checking the blocks. We could change that. Let's change that real quick. Okay, so we just need to do check place or break block. That is this thing. Where do we use that? We use that here. Okay, if not main HUD, not viewing crafting screen, not main HUD is paused. This is in what? This is in update creative. Let's go to update spectator. Actually, wait, let's go back there and check place or break block. Let's go back up to here. Copy this. Okay, and then let's go down to update spectator and we will paste it. There. Inventory. Does inventory really matter? No, we'll just zero that out. Okay, cool. So that should run the code at least so that we can see what's going on. Nope, we broke it. Cannot convert from initializer list to inventory. Yes, we can by doing that. Hopefully. SE Woods, I do the same. Run application, host, start new application, join, just to check if things are working properly. Repeat infinite times. Exactly. And it's like, this has gotten to the point where loading it takes so long where I'm like, okay, I need some sort of like small test world that I can do this a little bit easier with. Okay, cool. So now we can do this in spectator mode. Let's see. Does it... Let's see. Do we... Okay, here we go. I do not see blue vector or cyan. So I don't think we are actually... And the reason it's so buggy right now is because we're like raycasting from within a block. So it's kind of weird. But yeah, I don't see the cyan vector going down. So I think we are just losing that cyan vector completely. Okay. Let's get rid of that. And let's just do that. Maybe we can leave it in and say like note, debug, spectator, whatever. Okay, so let's go back down to here. We are losing one of those components, but it's good that we verified that. So now we know for sure. And SE Woods, that one advantage I have, loading is instant because there's so little data. See? I never thought that I would actually have to like get to a point where loading took a long time. And so this is also in debug mode, so it does slow things down a bit too, but yeah. So why are we losing tangent or perpendicular, which is cyan? So perpendicular is losing his component. Face components, face 1, 0. And I believe it's because of this. What would happen if we did, instead of he equals sign direction, what would happen if we said temp? What if he equals temp? And I think it is that bug that I was talking about at the beginning. And then I was like, oh, but it can't be that because we had the other bug. So I ignored it, but I think it actually is the problem. We'll see. Whoops. Let's get back up here. Weird that I was falling through the world. I think it was just like correcting my collision or whatever and just kind of breaking. Okay, yeah, this is a little bit better. So we aren't losing cyan now, but cyan is pointing in the wrong direction. So we just need to zero out the other component for our cyan vector, which would be perpendicular vector face components int face 0. But I'm guessing that's what broke it in the first place. Whoops, that should be face bracket 0. And that should be open bracket. Okay. Yeah, I think this is what made us lose it in the first place, though, because that's essentially what we were doing. Let's see what happens. Okay, do we have a cyan? I don't think we even have cyan vector down here now. We do have it up there now, but we don't have it here now. So what does that tell me? I think that what that's telling me is that we're just messed up here. Okay, so this is getting face 1. So I think our 1 index is broken here for top face. Should be X and Z components is what we're zeroing out, but it, should we have this flipped? Is that what it is? Should we be flipping those? I think that's what it is. If that's the case, that's kind of annoying, but we'll see. Fingers crossed. I think that should fix it, and then we can just go and swap the other stuff. Okay, we do have cyan in both again. I forgot to do one other thing too, which is we got rid of that. So we just need to make sure that this is not temp, but signed direction instead. So let's do that again. Okay, and let's go back into here. Okay, we've got cyan. We do not have cyan. What is going on there? Wait, is there cyan? No, I thought I saw cyan. So the white vector is our signed direction, right? I would point to this if I could, but I can't. So let's switch to the drawing screen real quick, because I think this might be useful to draw out and get a little bit better idea of what's going on. So let's go over here. Okay. So basically what we've got is our 3D cube space, right? Like that. And then what we've got is we've got a vector coming out. That's our white vector. And what we want is we want this vector. We want this vector. And if we're on this face, we want, this is if we're on this face, right? If we're looking out this way. So we want those 3 vectors. So this vector gives us, let's say that this is Z positive. So that's Z plus. Okay, so this would be Z plus. This would be, let's say this is Y plus, and this is X minus, okay? So basically what that A is what we'll call our guy up there. So what he would be is X minus, minus 1, Y positive, positive 1, positive 1, okay? So then to get X minus, what we have to do is, we'll call that P for perpendicular, right? What we want to do to get him is we want to get minus 1, 0, 0. For F, which is our forward vector, we want to get 0, 0, positive 1. And then for tangent, which is T, we want to get 0, positive 1, 0. So if we're looking at this face, which is Z positive, which we will call the right face. Okay. If we're looking at the right face, we need to zero out for our perpendicular vector, the X or the Y and the Z components. This goes the X in the Z, no, the X and the Y, and then this is the X and the Z for the tangent. So I think this is where my logic is flawed. I was zeroing out the wrong components. And that's why I think we're losing one. So maybe not, though. No, yeah, that's definitely, I think we've got something wrong here. Okay, so let's go back to the screen. SE Woods, if you made a linear story-driven game, I would think using a game engine would be much less work for the type of game you're making. Custom building seems more suited. Disagree? I don't know. I think you're right. Like, I don't really care about efficiency, though, too much. I just like learning about designing these low-level APIs and stuff. So, you know, I'm not... much less work, for sure. I do agree with that. It would be much less work to use a pre-built game engine for something like that. So, but I'm not that concerned with efficiency or anything. So, okay, so I think it's this logic that's flawed, is that we, or no, this isn't flawed. Yeah, because we've got Z. Let's see. Let's make this temp. And let's make this int face. I think that's what I want to do, right? Yeah. But then that's essentially the same thing here, isn't it? Yeah, that's not, okay. Okay, let's go back to the drawing screen real quick. I do need to do a little bit more drawing first, and then we can go here. Okay, let's think about this a bit more. So for the right face, for the top left corner, we want to get those. Is it the same here? We want this vector, we want this vector, and we want this vector. Those are the same three, right? So in this case, right here, we'll call that B. We would have X is positive 1 now. We would have positive 1s. Okay? So then our perpendicular vector would still be positive 1, 0, 0. Our F would be 0, 0, positive 1. And our tangent would be 0, 1, 0. So we're still doing the same components. Okay, so this is good. And then down here, do we still do the same components? We still need the same components. No. Yes. Same components there, same components there. That's good. Okay. Okay. So basically for perpendicular, for the right face, we need to 0. So perpendicular right face. We need to 0 out the Y and Z components. For the right face, for the forward vector, we need to 0 out the X and the Y. For the right vector, or right face, tangent vector, X and Z. Okay, let's try and get the right face working. Won't the cross product of Y and Z work? Cross product of Y and Z. Yes, because that should give us that. Wait, will it though? No, I don't. Because we have the same Y and Z components here and here, but the X component is changing. Even though these are the same directions. I don't think the cross product would work because for this vector, we need to look right, but for this vector, we need to look left. Whereas the cross product would give us the same direction either way. I'm not sure if it would give us right or left, but it would give us the same direction for both those. Yeah, so cross product would like point this to the left or something every time. Because I think I tried that at first and then that was broken as well. And that's when I switched to this technique. But I think we're getting somewhere. Okay, so for the right face, what we need to do is we need to, for the perpendicular, let's do this. We will say, instead of something like this, int perpendicular comps to 0. We have 6. We have 2 equals. Okay. 2, 3, 4, 5, 6. Semicolon. Let's just copy all this actually. And we'll paste it there. Okay. So for the perpendicular, we know for the right face, we need to 0 Y and Z, which is 1 and 2. For, this is going to be different. Okay, let's do that. For the normals, or forward, we'll call this. Okay, forward comes to 0. For the right face, which we just did here, X and Y, which is 0 and 1. And for our tangent vectors, this is our tangent comps to 0. For the right face, it is the x and the z, okay? So that is x and z. So we'll do that. We'll say temp, signed direction. Let's just not zero anything out with the signed direction, okay? So let's actually just comment that out. We'll say temp is signed direction, or we don't even need this anymore, okay? Say that. Okay, so now for the tangent vector, we'll do this twice, and this will be tangent comps to 0 for our face, and we need to zero out 2 of them, so that's that. Okay, so we'll do that. Perpendicular, similar stuff. Change that. Perp comps to 0. That. Okay. So we zero those components out, and then for the forward vector, we've got the forward vector based on the hit normal, so that should be fine. Yep. Sorry, End Hunter. You just flip which one is crossed, don't you? So left is YZ, for example, and right is ZY. Oh, yeah, you're right. I'm not too familiar with this, just learning it all. You are right, so I would do the reverse of that, but I think that means I would still have to hard code that logic somehow in here. And cross products confuse me as well, so I'd rather do this where it's like extremely explicit because I'm hard coding which faces we need to zero and stuff. But we will see. I think you are right though. That's how you flip it based on those directions. Okay, this should be sign direction is what we want this to be now. Okay, we'll call it that. Cool, so let's do that. Let's see what happens. For the right face, it should be fine. In the right face, I should actually do something so that we know we're looking at the right face because I still don't have axes. As you would say, I also enjoy much of the programming that goes along, but I also understand people going with an engine for certain projects because it frees up time for the developer to spend on game stuff. Gamers of the game do not care how it's made. Still agree with you, it's enjoyable. Yeah, absolutely. You know, I'm not doing this to make money. I'm doing this because I want to make a game and I enjoy learning about this stuff. So totally agree. Let's just check this too. Okay, so the right face is the one we should have working. Oh, I guess we should just do if face. Okay, there we go. Let's just we'll draw a second box just so that we know we're looking at the right thing. So we'll do this twice. And we'll do this in red. Okay, that way we know we're looking at the right face. And this will be 8, 8, and 8. Okay, let's see if that works. But yeah, totally agree, SE Woods. That is my main motivation, is just to learn stuff. So, you know, if you're just looking to make some money or something, I'd definitely say go with an engine, right? Okay, that's not the right face. That's not the right face. That's not the right face. I'm guessing this is? No. Don't see red. I don't see red. Don't see red. And I don't see red. Do we not have the right face here? Let's log something, because that's always super obvious. G logger info right face. Okay, let's see if that works. That's not what I meant to do. Oh man, I keep getting these stupid spam messages that are sending it as a group message, so I can't block it, and it is so annoying. I need to install an app that blocks spammers or something, because this is just getting ridiculous. Okay. No logs, no logs, no logs. Why am I not getting any logs? Right face? The right face shouldn't be here. Why am I not getting a log? At least one of these should be. Am I looking at the right thing? Normal to face, res.hit normal. If x is greater than 0.5, front, back, top, bottom, right, left. I guess we should be doing 0 here, but I don't think that should matter. I just need to make sure that I'm writing my code correctly so that we can actually tell what the problem and where the problem is, because I keep going all over the place with this stuff. Okay, let's see. Okay, there we go. So that's the right face. Okay, so that was broken. And the right face is correct. Look, we're getting the right blocks for all those. Okay, let's, first of all, let's get rid of that log. Now I got to make sure that that normal thing wasn't the reason we were getting the wrong blocks. I don't think it is, but... More spam messages. I just keep getting messages from these stupid scammers. Oh, scammers annoy me to no end. Like, truly despicable people. Okay, we're getting almost the right blocks here. Something is wrong. We'll fix that in a minute. Are we getting the right blocks now? We are. It looks like getting the right blocks now. Let's switch this back. Hopefully it wasn't because that thing was broken that we were getting all the wrong blocks. Because if it is, that is very annoying. So what was I doing before? I was doing this, and I was doing not that, and not that. Oh, I'm also doing that, which shouldn't be happening. But this is what I was doing. So let's do this. Tangent, vectors, and I think that should be 0. Okay, so this is what I was doing before. Let's see if this works. And I just had a bug in another place. Scammer is all focus on money. It is true. But it's focused on money, and it's focused on, I don't know. It's scamming. It's just not good at all. Guys, okay. Okay. So it looks like this works. I just had all my other code wrong. Look at that. We're getting the right blocks. Right blocks, right blocks, right blocks, right blocks. That's all correct. I just don't know how to code. That's what's incorrect. Well, that's annoying. So we have learned absolutely nothing doing all this stuff. But let's go ahead. Delete this. Delete this. We don't need that stuff. Delete this. Delete this and that and that. So apparently this is somehow working. I thought it wasn't, but it is. And I don't need to do that. I need to do that. Let's make sure everything's still working okay. And let's also get rid of this. Okay, let's make sure it's all working all right. Okay, let's go big screen, load world. Let's make sure we get the correct vectors on the screen. Okay, look, we've got blue, we've got blue, we've got blue. Everything is good. Yep, we've got all 3 vectors. We're getting the correct blocks. Okay. So in other words, our code, the code up there was correct. It's something else is broken. Let's go ahead and change these to sand because that will be easier to tell if something is wrong, which there is because we know the ambient occlusion is still broken. Okay. There we go. We got some sand. Let's do that and that. Okay, cool. So Still broken. And we learned nothing. We did learn that it was all good. I love it when 30 minutes just shows only one line of code was off. I know, for real, right? What was wrong was that this was supposed to be zeros and not 0.5s. Man, that's annoying, but whatever. Okay, let's go ahead. Let's commit this so that I don't have to redo this again next time I want to debug. Commit -m, add debug for ambient, debug cube lines for ambient occlusion. And let's just say like AO debug stuff. That way I know where to look next time. So I don't have to go through this again. This code is committed. We've got it there. Yep, all good. I secretly enjoy YouTube channels that waste scammers' time. I do too. I don't secretly enjoy it. I openly enjoy it. What's his name? There's the one Irish guy who I just really like. I can't remember his name now. But he's good. An Irish guy that calls out scammers. Kit Boga? I don't think so. Man, I don't know why I can't think of his name too. Yeah. Jim Browning. Thank you. Hilbert curve. That's what it was. Thank you. Yeah, that's who it is. Langor's best part is when you find out it's the debug code that's wrong. I know, right? So the debug code was wrong. It looks like that code is correct. So now I am completely lost as to why this is all broken. So we are checking the correct blocks, right? So if I change this block, we should see a change in the ambient occlusion here. So if I do that, does it change anything? No, it does not change stuff. So what about when I do this? Does it change stuff? No, it does not. What about when I add up here? Nothing changes. Okay, what about... Oh, that's because I'm looking at the wrong place. It should be these things. So if I change this, that corner is not changing. Why is it not changing? What does change it? If I click this... Okay, that does change it. That does not. That also does not. So why is that? It should be getting 0 rotation. Jim Browning, what a lad. Yeah, he's great. We should be getting 0 rotation, so we should be getting these 4 blocks, which means that we should be getting this block and this block affecting this vertex down here where that blue highlight is covering. But when we change this one, it changes, which makes sense. But it also means that it shouldn't... This should be affecting it too, and it doesn't look like that's changing any values, and neither is that. Why is what I'm wondering. I've got to think about this again. Okay, so basically, if we're looking at this vertex from here, this has... Okay, yeah, this has 1 block affecting it to the side. So this should have 1 ambient occlusion. And then if I were to... Wait, am I thinking about this right? Oh, I want to be looking at this corner. Sorry. Let's look at this corner. Okay, so the top face of this block right here. So if I place a block here, it doesn't change. If I place a block here, it doesn't change. It should be changing. If I place a block here, it doesn't change. We should be getting a change there. We're not. So that's broken. Sam, the 0.5 offset from the vertex offset variable, is that it? Do you think so? You could be completely correct. And if that's the case, I've spent so much time on this for no reason at all. You know what, Sam? I think you're right. I think it's because of this, isn't it? I'm subtracting 0.5 and adding 0.5, which I don't think we have to do anymore. If we look at the opaque shader, what did I change? Yeah. Rotation. How do we rotate? Yeah, we don't. Yeah, I think you're right. That. I think that's going to fix it. And we don't need that anymore. because now we're centered on the origin. I think that's going to fix it. And if that's the case, I'm really sad because that was annoying. And we might need to add another 0.5 offset after that. Let's just check. So we do that, and then I might need to add a 0.5 offset. Okay. Looks a little bit better. We might still be missing one thing, which is I think we need to do that. Plus that. Okay. And then we should be good. Let's see. Are we good? Look at that. I think this is good now. Man, Sam, thank you. All that time for such a simple thing. So now if we place a block there, it changes that color. If we place a block here, it gets darker. If we place a block here, it gets darker. Yeah, that's looking good. Man, I was saying this from the start. Sam, I'm sorry. I need to learn to listen to you because, oh, that's annoying. I thought you were saying the 0.5 in the debug code, which is why I kept looking there. And it was all along. You were like, no, it's just this. Let's double check real quick. Let's see about the stairs and stuff, because I want to make sure those are all correct. Yeah, so this is something else I need to fix, which is like we need to interpolate here, which I still haven't added. But stairs look correct. Stairs look correct. Yeah, we need to add that interpolation there because I think that's why it's kind of... And it's broken in the center blocks. So those we need to figure something out for. And up here too. Yeah. So I'm going to have to come up with a more complicated solution eventually. But for the most part, yeah, looks much better. Oh, man. Yeah. Keck is right. Keck W. I agree. Well, glad that's out of the way now. And you know what I'm going to do is I'm kind of wondering if I should even remove this stuff or if I should just leave it here. Oh, wait, not that. This stuff. Because this is useful. Let's do this. We're going to go and say comment all this out, and I'm going to leave it in here for now. And I'm just going to put to do zombie code remove. Not zombie AI, but dead code. Okay, not to be confused. Logical Bomb, thank you for subscribing. That's pretty awesome. Got a new subscriber. I need to add some subscriber benefits for you guys because I still have not done that. And I got more scam texts. This is very annoying. It sent a read receipt, and I think that's why they keep sending messages now. If anyone has any apps to avoid that type of stuff, let me know, because I'm going to have to install it. Okay, so we're good here. I do still need to fix the light colors. That is something Sam has showed me a fix for. I'm still going to wait on that a little bit, because you can see the lights are just affecting the shadows instead of actually affecting, like, the highlights. It's kind of reversed. But I want to move on to what I said we were going to be doing this episode, which is block drops, right? Yeah. I never get messages from scammers. I usually don't either, and I just started this morning, and it's really annoying. So I'm not sure why it just started all of a sudden, but let's go ahead and just do that. Okay, so yeah, see, we got to fix stuff like this too. Like the ambient occlusion is broken here. Since this is in the center, it's 0, 0, 0. It doesn't know what to do. And it kind of just breaks for that vertex because it doesn't know what blocks to check. And what blocks should it check? Technically, that should just be, it should be checking like the interior corners of this and like adding ambient occlusion within there, which is, that's a complicated thing because we should be getting ambient occlusion in that center vertex, but technically it shouldn't be checking blocks. It should be checking the vertices around it. And that's just a complicated scenario. Not sure how we're going to do that. SE Woods, growing up before having a computer were common. Technology has come so far in such a short time. Yeah. Okay. So how do we want to do this next part? This is what I'm thinking. Block drops. Can't you just hard code it? I could. I don't like that solution though, because then when we develop other blocks and stuff with similar things, it's just going to break, which isn't the greatest. Yeah, because then for like these guys, we should have some ambient occlusion there too. So it's not the greatest solution. I'd rather come up with a generic solution that just works. And then once we have that, it should work for all the vertices and all block types, and we should never have to worry about it again, which is ideally what'll happen. But that's another day. I want to focus on the block drops right now, which we can do pretty easily now, right? Okay, so let's think about this real quick. First of all, let's commit that code. Git add dot git commit dash m fix AO for custom block types. Okay, so we got that committed and pushed. Okay, so custom block types. How do we create a block? We know how we create a block because we do it here. Right? This is the code to create a block. And I'm going to abstract this out because we're going to need this in a few different places now. So let's copy this. Okay, maybe we can't abstract this entirely out because it is kind of unique to this. What are we going to do? We're going to go into constants.h. Yeah, let's go into here. So I've got this thing, vertices init free, and what I want to do is I want to essentially do like a engine core API void. Wait, no, this is the wrong one. Sorry. Constants.h. We don't want to be in here. We want to be in here. Do I not have one inside the game itself? Because this is where I want to be. No, I do not. Okay. Let's put this in our render. I think this is going to be the most... Yeah, okay, let's do this. We're going to add a new thing. We're going to call this our instanced... Because this is going to be like... we're going to be implementing some sort of instancing, and so we need a way to get block models and stuff, which I guess is just a mesh, right? So let's call it mesh. But I don't like that, because it's for specifically block types. Let's do this for now. Okay. Hash if not defined, crumble, mesh, h, hash define. That. Okay. So we'll say crumble. Okay, mesh. What does a mesh consist of? For now, we're going to have a VAO associated with it. And it's got some vertices and some indices. Yes. And some, yeah, okay. So we're going to need vertices, indices. What does a mesh's vertex look like? What do we want to contain in there? I'm trying to think. We'll do this the simplest way for now. We'll have a position, which is just a GLM vec3. We won't do any sort of compression, whatnot yet. We'll wait on that. And then we can add compression and stuff later on if we want to. For now, we're going to do the simplest solution ever, which is just position. We want a UV. Yeah, that should be it. Position and a UV. I mean, I guess we need a texture ID too, but we can associate the texture with, we don't even need to do that because we have just one global texture. So this should be fine. We just need a position and a UV. I do like that. It's pretty small, hopefully. Do that. Should this be a vector? Block drops requires entity rendering, right? You'll do entity rendering, right? Yeah, sort of. I'm going to go like, what's going to happen is we're going to have entities that have this mesh component, which is going to then trigger some sort of instanced rendering inside of our render. So it is sort of like that. That's what I'm going for a little bit. Yeah. You think vector is good here? The reason I don't want to do vector is because it's like a vector is for a growable array, and technically we will know exactly how many vertices there's going to be for each mesh. And I'm like, why put that in a vector when it's like I could just do this and then like number of vertices and just allocate it once and then be like, okay, that's, I don't know, like, because I agree with you. It is good. I mean, if I was doing like C++ proper or whatever, I would probably just do like that, because I know exactly how many vertices we're going to have at the time of creation of a mesh, and that's never going to change because meshes are going to be constant. So I think this is more the tact I'm going to go for. And then we'll just do this. So, but I agree. Usually, yeah, I think this is probably going to be the easiest. Oh my gosh, I keep getting scam messages, guys. This is really annoying. Okay, so we got that, and then we got number of indices, and uint, we'll do uint 16, because I don't see us needing 32 bits for indices. I don't see us getting that big. If we do, we have other problems. Okay, so I think this is sort of the layout I want to go for, and then we probably just want to do this, and this should be uint 32, and we should be good. Langurs, is it all from different numbers? Yes. Here, I'll show you guys. Look at that. I don't know if you guys can see that or not. I've just got these messages from like 30 numbers, and it is getting really annoying. I'm like, they have different area codes, different stuff. Oh, and it's a bunch of people. Okay, since they did a group message, it's all the people who are in the group message, and they're all sending stop to try and get... Oh my gosh, I don't know. Scammers are annoying. Okay. Anyhow, let's ignore that for now. So we're going to have a mesh. Mesh is going to have a vertex. That's 64 bits, 32, 32, 32. That should be okay. I mean, technically, we're going to have another thing here for like padding, but no sense explicitly writing that. So that's like, yeah. I like that. Cool. So we got that. We got our mesh vertex. Just turn off your phone for the stream. Yeah, let's turn it on silent or whatever. That's a good idea. Do not disturb. There we go. Thank you. Okay. So we've got this, and then what do we want to do? We want to be able to create meshes pretty easily. So like mesh utils, I don't know, something like that, maybe. Who knows? Yeah, let's do namespace mesh utils. Okay. And then what will we do? Ooh, okay, I just thought of something that's not very good. We can't really do this, can we? Oh, it's the phone, you get scam message. I also get that once in a while. Procedure, block number, delete message. That's what I usually do too. And they just keep like, it's, yeah. I'm going to have to start doing that. Why can't we embed UVs in the vertex? Because this means that we can't have one mesh with different textures, right? This is going to kind of break stuff because the way we have the textures working. So let's actually go chunk.h or blockmap.h. Let's go into here and see how we're doing it in here. And we're going to kind of do the same thing just so that we get that stuff a bit better. Okay, yeah, so we got, well, that, and then, let's see, somewhere down here. No, not that, chunk.cpp. How do we do it here? Let's see what we're doing in here real quickly. Okay, so, okay, we get this vertex. What does this vertex look like? And we're going to do something similar. Yeah, okay. I really didn't want to do this, but we're doing this. We're going to copy this vertex definition. That way we have like one common thing. I think this probably makes the most sense. So let's do that. We're going to use this vertex. I should probably call this something a little bit more explicit to like chunk vertex or something. Instead of just vertex, but I guess we're leaving it vertex for now. So let's call it that. Vertex. What is that? That is in world/chunk manager.h. Okay. So we got that. That's just going to be that. Oh, and I don't want to do that. I want to do this. Oh, I guess we can forward declare it too. Let's do vertex forward declare. And then we'll just add that inside. Let's create render. Let's see. This is in include. Let's go to source renderer. Add. And we're going to call this mesh.cpp. Okay, and then we're going to go and just include that. Include. This is in renderer/mesh. Okay, that namespace. Mesh utils. Okay, so that's all good. We're going to use the same definition and we'll kind of go from there. So that way it's consistent at least. Or you can create a software that does it all automatically. Hashtag side project. I might just install an app. I think that's probably going to be the easiest thing for the near term at least. We're missing namespace. Crumble. Okay, that's good. So we got our vertex, we've got our vertices, we got our indices, we got our VAO, we got that. But all right, that's good. And then this makes me wonder if we're like even actually going to use indices, if we're just going to copy the way that we're doing it in here, or I guess in here, which means we're not really even doing that. Maybe, I don't know, we'll see. End hunter, you could just block unknown numbers. Only problem is then private withheld or new numbers. Yeah, be added to contacts to be able to ring you. Yeah, and I mean, honestly though, if I do just block unknown numbers, they can still leave a message. So if it's important enough, they can just leave a message, and that might be the best thing. It's just annoying that we even have to deal with this at all. Like, it's just annoying. Okay. So we got our vertices, we got our indices, and then what we want to do is want to have like a, I don't even know if we need like an init. Yeah, let's do that. We'll do like an init, and we'll have a free, and then what we'll have is we'll have like an add mesh thing, mesh type maybe. Trying to think of how we want to do this. What's the best way? Yeah, let's just do add mesh, and then maybe we'll just take a string and we'll do it this way for like some sort of unique identifier. That way what we can do eventually is we can have something like that. Right? And then what we can do then is we can just grab the mesh, grab the VAO, do all that stuff. Yeah, I think this is probably going to be the best way to go about this. So we'll have add mesh, and then what we need, so we've got the mesh name. We also need to pass vertices somehow. I'm thinking, okay, so what I'm thinking of is, do I really want to do this? Because what I could do is I could just change Where is it? Somewhere in here we've got block type. Yeah, okay. What I'm thinking is we could just change this to like mesh type, right? And then we could just use a uint8, like an enumeration instead. Sam, you could store the block mesh into your block definition. And it is. It is stored in the block definition because we've got like this block format thing and all that stuff. Yeah, because we do. So the block format, so it is because we have this thing down here, which is like block vertices. Yeah, so we got this thing, which is basically all that stuff. But the thing is, we're going to need like an instanced version for entities, which is a little bit separate. Little guy, question that you probably can't answer here. What is the highest mountain in Hungary? I definitely cannot answer that. And so my only thinking is like, oh, maybe we could add like mesh type here instead. And then we could also add in the future like zombie. And then we could add like player and kind of do it that way. I don't know. For now, we'll do this. And then we could have like a, I don't know. This is like, why is this so tough? This should be the easy part. Just do something and stick with it. This is what we're sticking with for now. Okay, it's just gonna be a string and then we'll change it in the future. To do, change this to an enumeration. Okay, so we're gonna add that mesh, and then what we want to do is we want, first of all, since the first thing we're focusing on is block vertices, we can just take in a const block vertices, which is this. So we'll just take that for now. Block vertices. And then in the future, we can add other methods like void, add mesh, const, stood string, file path. And then that will be for like, you know, adding it from an FBX file or something like that, right? So that's the direction we'll go. Forward declare that. Okay. So that should be good. For now, this is what we'll do, and we'll just use a name, and we can just change the enumeration to a name, and we'll live with that, and then we can change it. So let's go ahead. We will copy these. Go ahead and add them here. And then I'm going to say internal variables. By the way, my C++ is not normal C++, so if you're new here, that's why I do weird stuff, but you know, it is what it is. glogger error to do not implemented, add mesh from file. Okay, so got that. Static stood, no, we want Robinhood unordered map, stood string to mesh. That's our meshes. Okay. Equals that. I know it's not, you don't need to explicitly initialize whatever. Yeah, I'm doing it anyways. So, you know. Okay, so we got that. And then when we free meshes, what are we going to have to do? We're going to have to go for auto KV. Can we do that? No, I don't think we can. For auto pair and meshes, pair second first. Do I even need to do a reference here? So this is one thing I'm always like, is an iterator lightweight? Do I need to do this, or is this fine? Auto pair. For any C++ people, let me know, because I am interested in that. I'm going to leave it like that. So first, that's going to be that. So we want to do second dot indices. Okay, so we want to free this stuff. And we want to... It's fine. Okay, thank you. I've always, like, I never knew whether to do a reference there or whatever, because I was like, does it matter? Or is the iterator small enough? I don't know. And then we also want to do vertices. And then it... so the ref just means that you don't copy it. That's what I thought. And so it's like, does it matter if you copy the iterator or not, which I wasn't sure on. But yeah. And in C++ 20, you can do key value. That's pretty cool. C++20 has some cool stuff, right? Okay, so then what we want to do is we want to do GL delete buffers. Okay, so we actually need to store the VBO in here too, so that we don't lose track of that. So we're gonna have a VAO, VBO, and I guess technically we could have an EBO. We'll see if we actually stick to that, because I don't think we will, but we'll have it in there for now, and then we can remove it if we need to. So GL delete buffers, one VBO, I guess pair.second.VBO, the EBO, and VAO, and we want to do GL delete vertex arrays. Okay, got all that. Isn't that feature available in C++17 as well? Is it? What is key? Ah, it is. Thanks. But why is it saying that's a crumble mesh? Shouldn't that be like a reference? Yeah, see, okay, auto doesn't deduce references. A possibly unintended copy is being made. That's not cool. I don't like that. Okay, so that's going to copy the entire mesh, which, like, technically it's not that heavy because it's just pointers, but still, I don't like that. Okay. It does look like it works, though. Or maybe it's just showing that it works because, I don't know, because I've got C++17 on here. Who knows? I don't know. Yeah, it doesn't deduce the references, which isn't cool. Okay, so we got delete, so that should clean up everything. We're good here. Now when we add a mesh, how do we add the mesh? We add the mesh by doing something similar to this. Right? Yeah. Well, no. It's a little bit easier, isn't it? So our block vertices, what do those have? Those have... Come on. I got to include block map. Okay. Okay, so we've got these face indices. We got face indice lengths, global index start, vertex offset, number block rules, number vertices. Okay, so we got all this stuff. For now, let's just copy our code here, and then we're going to modify it, copy it into that mesh, and then we're going to remove the stuff we don't need, all that good stuff. So let's copy that. Miji, thank you for following. Good to see you. Okay, so let's do that. Whoops. Not want to do that. That. Control KD. Okay, looks like we're good here. Now let's start removing the stuff we don't need. So we're going to say block vertices. Okay, so this is like an optimization type thing, right? Oh, I'm not at the top of this yet. Let's go all the way to the top first of all. Okay, so we're at the top. We don't care about this stuff. Let's remove that. Okay, vertex position. We don't care about this. We just want local positions because we're going to add like transforms and transformation matrix, all that stuff. So yeah. You can do auto ref first, second. But is that just a reference to the iterator, or is that a reference? I don't know. I'm going to see what Visual Studio says in a second. But first, let's get rid of this stuff. We don't care about this stuff. Oops. Okay, so format. We've got the format. Wait a second. Okay, this is a problem. Kind of. Ooh, okay. So somehow we're going to have to instance the block ID. Or I guess just the texture ID. We're going to have to instance the texture ID. And so we can't actually embed the UVs in our attributes. Let me think about this for a second. How do we get our texture, our UVs from in here? So what do? We say extract text chords. That gets takes in data 1 and face. What does data 1 give it? Data 1 gives it the texture ID. We can embed the texture ID in here. That has to be an instance attribute. Okay, so we're gonna have to do things a little bit differently. The mesh is not going to use vertex like I thought. We're going to use mesh vertex, which is what I originally thought. So let's do that. We're going to have that, and then we're going to have just UVs. Wait, let me think. I think we're just going to have that. That's literally all that's going to be a mesh vertex. And then everything else is going to be instanced. We're going to instance the texture. We're going to instance all that stuff. Will that work, though, is what I'm trying to think of. No, it's not going to work. Why is it not going to work? Because what do we do here? We embed the face and the vertex offset. Oh, no. Okay, so that will work because the texture coordinates are just based on the vertex positions. Okay, I think this will work. Sorry if I'm not making much sense here, too. I'm just trying to, like, think all this through. So I think all we need to do is embed a position, and that should get us, if we have the texture ID instanced, we should automatically get the rest of our stuff for free. Okay. So this is fine. We don't have to worry about this. We don't have to worry about this. We've got our block vertices already, so we don't have to worry about that. We don't care about rotations. We don't care about rotated face maps. Okay. Don't care about block rules. That's all chunk stuff. Where does that go to? That goes down to here. Let's remove that. Okay, so here we go. This is where it starts getting kind of interesting. I just got to make sure we're doing this correctly. So each face has a certain amount of vertices. Do we have like a block vertices dot number verts? Okay, cool. So we do. We can allocate that up front. That's good. Okay, we don't care about this. I mean, technically we do care about this, but it doesn't matter too much. Okay, then we do this. This is whichever face. We don't care about this either. Okay, so one other thing that we are going to need in here is a face. Which I'm just going to call data. And then the face is going to be embedded in here. Because a face is only like 2 bits, and I'm not going to waste like all that space. Okay. End hunter. Could you not do this when registering a block into the system? Add an item class that uses the block ID to get a mesh in texture. And then add the transforms to the item class as an instance specific thing. That's kind of what I'm thinking of, yeah. Is doing something like that. The position is going to be for like the vertices themselves, and then we're going to have instanced attributes for stuff like the texture and the transformations and stuff like that. So that's kind of the direction I'm going with this. Okay. So this is not too important. We can add that later if we want to. We don't care about this. And we don't care about ambient occlusion or any of that stuff. I mean, maybe sometime, but for now, we don't care about that. Okay, this is important, kind of. This is important, I think. Okay, global index start, which we can say is that. Okay, let me just make sure that's the right type. It's an int. Okay, let's change that. So that's that. We do not care about this stuff. We do care about the vertex offset though, so I will keep that there. Yeah, none of this stuff matters, so we can get rid of all that. Okay, and then this vertex offset is going to be our position, so what we can do is we can say that's that. We might need this. I don't think we do, but let's keep it around just in case. So let's do that. Make sure that's the right type. That's an int. Okay, cool. We're good there. And then we get this compress. Okay. So what do we need? We need an array of mesh vertices equals that times how many do we have? That's how many we have. Okay, so we're gonna do that. Okay, we do that. We've got an array now. We need indices, which I think I said we're gonna be uint 16. Star. That times indices. Okay, we need the number of indices. I don't think we have that as a global. We don't. So what we can do is we can count them real quick. We'll say, we'll just call an int. Number indices equals 0. Block vertices dot face indices dot length. We can't do that. I think it's cube face length. Okay, so we'll do that. And then we'll say number indices plus equals block vertices dot face indices lengths I, and that should give us the lengths. So that should give us how many indices we have. So now we can just do that. Okay, so now we got our vertices, we got our indices, we have the totals here. It's good. Now we just need to copy that stuff into our array, and we need to copy the positions, and then we should be good. I think that's basically it. So we might not even need this stuff too. And then what we'll do is we'll start with like the simplest rendering possible, which is like no textures. Just see if we can get the models in the game. And then once we can get the models in the game, we can move on to textures and stuff. Get all that working properly as well. Okay, so if we go and like, okay, yeah, so we do want to loop through each face. No, we don't want to. We want to loop through, let's do this. For int face equals 0 until face is less than that. Okay, so we'll loop through all the faces, and then what we want to do, or do we want to do that? Wait, let me see. Block vertices. Do we have vertices? We do have vertices. And what is this? This is just that. Let's actually just do this. Number verts I++. Okay, so we're going to copy all those into those vertices. We'll say vertices I equals block vertices dot positions vertices I. And I actually think these are the same type, so we might be able to just do mem copy. This is a glm vec3 star. This is a mesh vertex star, but yeah, I don't want to actually copy that because it's not going to work. Okay, so we'll just do position. That works. So we're going to copy all the positions into there. We also need to copy the face. See, this is where I'm thinking we might have to duplicate stuff. Do we? This is the number of unique vertex positions. This might actually not be correct. Let's see. We need to go face equals 0. Face is less than int cube face length face plus plus. Okay, so we need to go through each face because we do have different vertices per face. That way we can get different textures per face. And then what we have here is we have face indices lengths, right? Which gives us the vertices that deal with this face. I guess we need to count the number of unique vertices per face, which is kind of annoying, to get the total number of vertices that we actually need. And this is where I'm about to say, screw it, let's not even use indices at all, because what's the point? We're gonna do that for now. Later, we'll do that later, okay? Yeah, let's just do that. So we'll do that. And then we'll add indices at a later. Vector lol. Okay. So we'll go through each face. Whoa, Essie Woods. What does that say? Gifted a tier 1 Demiri 4F, TL Follow, Eddie Dev, Sam, and Tim Player. Essie Woods, thank you. Gifting 5 tier 1 subs. That's pretty awesome. I'm really going to have to come up with some subscriber benefits so you guys can all get something. But yeah, thanks, Essie Woods. Hopefully we can make some progress too to make it worth it. Okay, so let's go. We've got the faces here. And we want to count up how many. So I think this is going to be like how many indices we need if we were going to copy it all. So this is also the number of vertices. Let's just change this. This is going to be number of verts instead, right? We're not going to worry about this. This is going to be that. Okay, and then what we can do is we can just copy directly into this array, and this will be like our triangles, and this should just work. So then if we get number indices equals block vertices dot face indices lengths face. Is that right? Maybe it's that. Okay, yeah. So that's the number of indices for this one face. Equals 0. I guess we'll call this element because we'll call this index. Okay, index equals 0 until index is less than number indices. Okay, that's going to give us each index. And what we want to do is we want to copy that into our vertex array. So then our vertex counter is 0 to start with, and we do vertex counter plus plus for every index we copy in. So then what we'll do is we'll say vertices vertex counter dot position equals, and we've got our vertex, let's see, vertex index equals block vertices dot face indices index. Okay, so this is going to give us the index into our vertex array. What's this say? Oh, this should be face index face index. Okay, so we got that. It's our vertex. Then block vertices dot vertices vertex index. I believe that's all we need. I do believe that should be correct. Let me just double check in the chunk. What do we do here? So we get the global index start, global vertex offset start, and I'm worried we might need to use that. Vertex offset index. Yeah, it looks like we subtract the global index start. Okay, I think I might need to do that too. And then what do we do? So what we actually need to do here is we need to do minus that. Let's just make sure that's correct, because that might actually not be correct now that I'm thinking about it. Okay, and then we get the vertex offset. Okay, yeah, no, that's correct. And then we do vertices vertex offset. Okay, so that is correct. Cool. So that's what we need. And then we can set the face easily too. Vertices vertex counter dot data. For now, we'll just say equals face. So that's going to set the bottom whatever bits to the actual face, 0 through 6, which is going to match this thing. And then we can just kind of go from there. For now, we don't care too much about this. To do, compress some data into here. Okay. And I guess technically what we could do is we can eventually just like fix this up too, so that we use some of the same textures and everything. That's future problem though. Okay, so that should just copy everything, and then we should just have a valid array of triangles in here now. So then, what do we want to do? That doesn't matter anymore. Okay, just making sure. That should copy it. We have those in that vertices array. And we want to add that mesh now, right? Yeah, so let's say mesh. New mesh dot that equals number of verts dot VAO equals, okay, now we need to create the VAO and VBO and stuff. We'll do that in a minute. Vertices equals that. Okay, let's create VAO and VBO. GLGen buffers, one that bind buffer. I believe that's what we want, an array buffer. Yeah. And then new mesh.vbo. Bind that, and then what we'll do is we'll say buffer, nope, GL buffer data. Okay, and that will do array buffer. Size is gonna be size of mesh vertex times number verts. Data is going to be new mesh dot vertices. Usage is going to be GL static draw. We shouldn't be modifying this. It should just be once and done. So once we upload this, that is it. We also need the VAO. GLGen vertex arrays 1 and new mesh dot VAO. Okay. Bind vertex array. Okay, so we get our VAO, we get our VBO, and technically the VAO is unnecessary since it doesn't matter too much anyways. Generate the buffer, bind the buffer, buffer the data. So now we should be good. This mesh should have a proper VAO, VBO with the data uploaded to the GPU. Sorry, okay. Let me drink some water real quick. So, last step, what do we want to do? Meshes, mesh name equals mesh, new mesh. I guess what we technically want to do, yeah, no, that's right. Yeah, okay. So that should insert it into our unordered map, and we're good. I guess what we want to do is we want to say dot find does not equal meshes.end. This is bad. Tried to add mesh twice. Okay, we don't want to do that. And then we actually want to do this at the top so we don't allocate memory. Okay. So we just like early out if we try to add a mesh twice, because that's wrong. We don't want to do that. And then if not, we just go ahead and add it. Okay, cool. I'm feeling good about this. I think this is good. Get mesh, what do? We just say, and this should return a const mesh ref, which it does not, but it will. Cool. We need a null mesh too to make sure this works right. So static mesh, null mesh And then what we can do eventually one day is like create the broken model, which is like some pink model or something or other that's broken. And that way we know when we have a broken model thingy. Yeah. If that makes sense at all. That's what this null mesh is going to be. And null mesh dot VAO is going to be 0, number of vertices, 0, dot VBO equals 0. And then I might actually change that. Dot vertices equals 0. Okay, let's actually change this to what is this? VAO is a uint32. Let's change this to uint32 max. Okay. And then what we can do is we can add just a little helper thing on here, which is just inline bool is null. And we'll just return VAO equals that and VBO equals that. Okay. Langors, subscribe to tier 1. Hey, thanks, Langors, for 4 months. Hey, thanks. Man, I don't know. This is a great stream, I guess. I'm also going way longer than I usually do. It's been 3 hours, but we're making good progress. And I kind of want to, I'm enjoying working on this. So I want to get this part done and see what happens. Okay, so what we'll do is we'll say if meshes.find mesh name and return meshes mesh name. Actually, we don't want to do that. We want to say equals meshes.at mesh name. So that should throw an error if it's broken. It shouldn't be broken because we've done that. So it should be there. But, you know, I guess we could just do that, right? Okay, otherwise. Okay. So now we got the null mesh. And then what we can do is if a mesh is null, we just skip rendering it. In the future, we'll render it, but it will be something else. I don't know. It'll be like some custom model that's like there to specifically show us that something's wrong. Okay. I think this is good. We are good. Let's go ahead and initialize some stuff. So let's go into block map. First of all, let's go into crumble app.cpp. Yeah, let's go in here. Let's say include render / mesh. Move that up there, and we'll go down here. Say render. No, we want to say mesh utils in it. Okay, so we got that. That's after we initialize everything else. I like that. Let's do mesh utils free down here. Is this right? Wait, let's see. Where is my global free? So we get the registry in render physics. Where are we freeing the physics and stuff? Let's see. I thought that would be here. Free all resources. Important. Scene gets freed first. That it queues all tasks. Saving. Blah, blah. Oh, okay. I think it's right here. So then we would add this. Free. Okay. That sounds right. Lol guy, did you know that Minecraft unloads the default texture pack when encountering very specific unexpected data for some reason? I did not know that. I wonder what the very specific unexpected data is, though. Okay, sorry, I'm going to get another drink of water. Okay, so we got our mesh utils initialized. That's good. Let's go into block map. And when we're loading all of those block vertices, we basically also want to add them to the other stuff. So where is... Okay, where is this getting called from? Load blocks. Is that right? No, that's not the one I'm looking for. We want load block vertices or whatever is what we want. Yeah, okay, this is what we want. So we want to do... So we do this, we load all the block vertices. After we load all the block vertices, we want to load them into our mesh utils thing. So what we'll do is we'll say afterwards, we'll say like for int I equals 0, or yeah, till I is less than block vertices, I guess block type. Do we have a none? We do have a none type. Length, okay. I++. Thank you, Charlie Pyre, subscribed at tier 1. Thanks, man. Oh, and Langors is gifting 5 tier sub 1s. Man, guys, thank you. To super... Okay, we just got another thing. What is this? I think it's just like playing out all these things now. Thank you, guys. Man, this is a really good stream, I guess. Okay, so let's change that to an int. A hype train is close is what Twitch is telling me. Sub, gift, or use bits now to start a hype train. Nobody needs to do that if you don't want to, though. But yeah, thank you, guys. That's awesome. Okay, block type length. We want to loop through all the block types and load them into our mesh utils. Let's leave that as an error so we can find that. Hash include renderer / mesh. Let's go back down here. Mesh utils, add mesh. Okay, so then what we want to do is we want to say magic enum enum name block type I. That's the name. File path. Nope, we don't want file path. We want block vertices. Block vertices I. I think that's what we want. It's something like that. It's up here is what we're looking for. Charlie Pyre, I don't know anything about programming, but I enjoy your videos and streams for a while now. Wow. Well, thanks, Charlie. Interesting too that you still enjoy the, I hope it's not too boring then and stuff, because I've always wondered about that, like especially the videos. I try to make those more entertaining for people who don't understand programming, but then I get programmers who are mad at me because they're like, oh, that's not detailed enough or whatever, blah blah blah, and I'm like, you can't please everyone, but I hope it's at least somewhat entertaining for people. I appreciate that though. Thanks. Just do it. Oh boy. Langors played Just Do It for 10 bits. I forgot about that, and that freaked me out for a second. Very specific unexpected data equals empty item model, you think? Okay. I don't know if you guys heard that Just Do It. Man, that freaked me out for a second. I was like, where is this coming from? And Twitch... I'm looking at this. I don't know. Okay, I don't know how Twitch works and stuff, but that was funny. Okay. So, empty vertices, all block vertices. This is what I want. Okay, let's go here. Somebody should check if Langors is fine. He's gotten bananas. No, I think he was good. He was trying to freak me out, I think, right? Or are you telling me to just like finish this? Just do it and finish this, which is also what I'm trying to do. So, let's see. Now we got bruh from Hilbert Curves. Okay, so I think this should be good. What's this saying now? This is a string view, so what? If we just do string? No, data. I think that's fine. Okay, let's do that. And that. Cool, we should be good. Okay. I think this is all we need. Now we should have the meshes in the world. I guess what we can do to test that is what I always do, which is we'll go into the player controller right here. And wherever we're hitting, we will draw some mesh. So what we'll do is we'll say, let's first of all get the mesh utils. This is a very bad place to put all this stuff too, but we're doing it. Okay. Remove me. Yeah. Hash include render / mesh utils. Actually, let's do this. I don't like this. Let's add this into our render. Let's be a little bit smarter about how we're going to do this. Okay, so let's go into render.h. This is in the correct one. Crumble. That is in the correct one. Cool. And then let's add this void draw mesh. Okay. And this will take in a const mesh ref mesh. And then it'll take in other stuff like const glm vec3 position. and whatever else we want once we get to that. For now, this is all it's going to contain. And then we will have a for declaration up here. Okay, and then we will have, that should be good. Now we need to implement this. How do we implement this? Let's go into render, CPP. Eventually what we're gonna do is we're gonna batch these draw calls together, count up how many instances we have, and then do that all in one instance draw call. But this is like preparation for that. So we got that. That is below draw textured cube, which is actually gonna not matter anymore, I guess. Draw textured cube, where is that? That's right here. Cool. So we got this draw textured cube. This mesh has a VAO. For now, we're just going to issue a draw call immediately. Let's go ahead and include render mesh. Okay, got that. Draw line, draw texture cube, draw mesh. Okay, so we got that. We've got the mesh. This has a VAO attached to it. VAO is valid. Let's go ahead. We'll say bind that. We will say we need a shader is what I'm thinking. Let's create glm mat4 transform matrix equals glm translate position. Okay, that's what we're going to do for now. That's our transform matrix. We need a shader. Let's go to our shaders. Yep, we're going to add one more static shader. This is going to be our mesh shader. Okay. Draw mesh. Let's go back down here. So for now, we don't have that actually working. We will in a minute, which is fine. So we'll say mesh shader dot upload mat4 that. Oh, and we need the variable name u transform dot data dot, what is this? GLM value pointer transform. Okay, that's what we want. So that should do that. What is this saying? No, nothing to convert float star to that. Oh, I don't need to do this. Forgot that. Okay, cool. So we upload the mat4. We got that. We bound the shader. No, we haven't bound the shader. We should bind the shader. Okay. Bound the shader, upload the mat4. We've bound the VAO. Now we just issue the draw call. So we're going to draw a triangle. 0. Mesh.number verts. Yeah, and I think that should be it. Right? Yeah, I think that's it. And that should draw us a mesh in 3D space. It's going to mess with a lot of other stuff right now, but, you know, we'll fix that once we switch it up and stuff. I'll put it to do. Batch these into draw one instanced draw call per mesh. That's what we're going to do to make sure we just do that and we're not like lagging stuff horribly and everything. Okay, I think this is what we want to do though. So then in our player controller, what we can do is we can say hash include that to do remove me. Okay, and then let's go down to update. Actually, check place or break block. Okay. Let's go there, right here. And there we go. We'll say render, draw mesh. And we want to give it mesh utils, get mesh. And what are we going to give it? We're going to give it our sandwich. I think that's all we need to do. And that should do it. Position is going to be res.hitPoint or point. Okay. So that theoretically should work. We don't have the shader written yet though. So we need to write the shader. Also, we need to do Langor is gifting 1 tier 1 sub to Markins. Thank you, Langors. Let's go ahead. We're going to say mesh.null. If it's null, I thought I had a, did I not do that? Did I put that in the wrong place? No, we got struct mesh is null. Why is that not working? Oh, it's because it's not const. That's const. We're not changing anything there. Okay, so if mesh.is null, I know, right? I'm happy with the gifting. We got a lot of gifting going on, and I am totally cool with it, though. Thank you, guys. You're awesome. Okay, return. Seriously. So we've got all this. I think this is like the most subs I've gotten overall my entire time on Twitch, so it's pretty awesome. We're just going to early out if the mesh is null, because if it's null, it's broken, and then we can say g logger error. Trying to draw. I know, both of you, SEOs, you and Langors. Null mesh. %s. And we'll say mesh.name. I don't know. We don't have a name we can do, so we'll just do an error there. Okay. So that should be good. We need to get that shader. Static, I agree, Zam, as Zoding Daily would say. Static shader. So we need to go, let's go batch 3D voxel shader, and then we will also say mesh shader.compile assets /shaders /mesh shader.glsl. Okay, got all that. Let's go into VS Code and code that up very quickly. New, that's not what I wanted to do. Control N, save mesh shader.glsl, and this is in shaders, which is what I wanted. Cool. Let's not copy that because that's going to be annoying. So what we got, layout location equals 0 is going to be in vec3 position, and I've already realized we are going to have to fix something else. We're going to call that a position. Layout location equals 1 in uint a data. Okay. First of all, while I'm thinking of this, we also need to go into mesh. When we create our VAO, we need to create our vertex attributes, which is important. So we'll say gl enable array attrib. No, that's not what I want. GL vertex attrib array. Yeah, that's what I want. Okay. And then we'll say GL vertex attrib pointer, which we're going to do 0 is going to be 3 floats, not normalized. Stride is going to be size of mesh vertex. Void pointer is going to be offset of that. Okay. And we need to cast that to that. Okay. So that's that one. And then we also need data, which is going to be data. Okay. So that should be it. And that's just a attrib pointer I, because we're doing an integer there, lowercase I. That's 1 GL unsigned int. We don't have normalization parameter. And what vertex attrib pointer? Vertex attrib I pointer. I think that's what it is. What am I missing here? Vertex attrib pointer. Ah, yeah, I pointer. Capital I. Okay, so that's good. Since we're using an integer, we just have to use the I pointer version of this function. We've got unsigned and we've got the mesh vertex. We've got the offset. Should be good there. Cool. So now let's go back into the shader. We've got void main. Okay, we've got uniform mat4 u transform. At Games with Gabe, do you get anything when someone uses bits to play sounds on your stream? I do, yeah. So I think Twitch gives like, I have no idea how much Twitch gives me out of that, but I do know that they definitely give me a portion of it. So, yeah. I'll have to look that stuff up. I know like next to nothing about Twitch, but yeah. Gabe under his camera for next stream. Today sub goal X out of 100, yeah. Okay, so we've got our transform. Let's do out. Do we need to do? No, we don't need anything out. Okay, so this is fine. We'll say GL position equals. We also need U projection equals. Well, no, yeah, and U view. So we're gonna do it all in here, which isn't the best, but it is what it is. I always forget what order to do this, so we're gonna copy that. And now it's correct for sure. Okay, so this is gonna take in a position, and we also need to do U transform. Okay, so that's all that stuff. We should be good now. And this is hash type vertex. And we want to do hash version 330 core. No, we're doing 460. Is that all one? I can't remember. No, it's 2 words. And it looks like I'm using 3. So do that. Hash type fragment. Hash version 430 core. And I did just hear something. Sufero for following. Thank you. Good to see you, Sufero. And thank you for following. Let's go ahead. We're going to say void main. And for now, we're just going to say out vec4 f color. Or I guess we could just call that color. I don't know. Doesn't matter. Color equals vec4. Red. Let's make it a nice red. 0.8 or 9. 0.11. 0.13. TNT Master. I think Gabe receives money when someone uses bits to play sounds. Yeah, I think that is true. So it does a portion of it. I'm not sure how much, but it definitely does. Yeah. Let's also do that just to be explicit. Yeah. And I think that's it. Will this work, guys? We've written a lot of, this was a lot of code. I don't know if this is going to work or not, but I think this is all we need. Let's try. Let's see what happens. We should see a sandwich at that point. I believe Twitch takes 30% and streamer gets about 70%. I think that's probably right. Yeah. And I just realized this is broken. It's not going to work. I don't even have to run it to know that. Why is it broken? Because we don't upload. We only upload transform. We need to upload the projection and the view too. So we're going to have to fix that after it finishes compiling. Cool. Would be worst. Could be worse. Yeah, definitely. Okay. Let's see. Generating code. It's going to be broken, so let's not even try it. Ah, we get a breakpoint too, so that's good. Unknown shader type. Oh, we didn't even... Yeah. Did I name that right? Where's this coming from? This is a horrible error. I need to fix this. What is the shader type I'm getting? Vertex fragment. Did I... What does it say? Type is vertex. Well... If type equals vertex, that looks like vertex. Huh. 1K follower soon. Oh, wow. That's pretty epic too. Thanks, guys. Yeah. That will be cool. Maybe we can hit it now? I don't know. We'll see. Okay. This definitely says vertex. V-E-R-T-E-X. V-E-R-T. So... how is that not equal? Am I missing something here? V-E-R-T-E-X. That is exactly the same as that. How is that not the same? Should say contains instead of equals. You think that's the problem? Is we don't have... Oh, I see. There's an ending character. Is that what it is? There's like a space or something? Yeah, there's a space at the end of it. You are correct. Let's... But I don't... Let's do type.trim. Can we do trim or strip? No. Stood string strip. Trim? No, I stood strip. Trim. I don't like C++, the way they do this type of stuff, but we'll do .contains. That works for now. Let's put to do here. I'm sorry. This is like to do strip white space when checking. Okay, we're putting to do for now, and then I'm just gonna change it in here because yeah. So what's happening is that space is getting consumed. Yeah, we're gonna do that. Actually, we can probably do that now. Let's do that now real quick. Because if I look at the way I'm doing that, type, we are getting it by doing, yeah, okay, so type equals that times to the end of the line. So instead of going to the end of the line, first white space char equals that. We're gonna do, can we do like regex? No, slash. Okay, we're just gonna do space and we're gonna say pose. Okay, first white space char. What does this return? Because we basically want to do the end of the line or the first white space character, whichever is first. Find first up. Let's look that up real quickly. What does it return if it's not correct? The position of the first character, if no matches, end pose. Okay, so we will do first white space char equals stood string end pose. That, otherwise that. Okay, and we do this, and that's good. Okay, cool. So that's basically gonna do the end of the line or the first white space character. And now if we change that back, should be good. There. Hopefully. That will do the, okay. You have to implement it yourself. Yeah, I know. That's just, it's annoying. Still getting the same thing? Did that not work? Oh, that definitely did not work. That's taking the whole... Because I'm missing one other thing. Let's see. So we want to do that. Okay, let's do this. Int type beginning equals, and then let's just get all this stuff so that this is a little bit better. So we got that, and let's get rid of that and that. So if the first white space character is end pose, we want to do end of line. Otherwise, if end of line is less than first white space char, we want to do end of line. Otherwise, we do the first white space char. Oh, there we go. I think that's what we want. Let's see if that works. And nope. What are we getting now? It's still consuming everything. That's weird. Oh, because I never changed it. Whoops. And then what we need to do then is we need to say that is type beginning. Or I guess type end would be better. Okay, let's see if that works. You're removing the first white space, which is after the first token. You want the last one. Is that what's happening? Let's see. Well, I'm going from the first white space character after position, which position is right after the hashtag type. So are you saying, I think you're right. I think we might need to do +1. Or begin. Is it begin? Where is that? Yeah, it should be this. That's what we want. Okay, let's see if that works. It's going to work one of these times. Okay, it worked that time. We're getting another error. Cool. So that's fixed at least. Pretty ugly code, but whatever. Access violation. We're out of bounds for whatever reason. What is I? That's wrong. Oh. Whoopsie. That's what that should be. Okay, let's see if this works now. We're slowly making progress, guys. We're almost there. And, okay. So, we should get sandwich where we're pointing. Hopefully. No, we're trying to draw a null mesh. I'm probably just calling it by the wrong name. Let's see. So if we go back into block map, which is now out of here. Okay. Let's go ahead and say, actually, let's go down here. Glogger info successfully added mesh. Mesh name .c string. Let's see if we get sandwich in there, which we should if all of this is working properly. I forgot a semicolon. It has been 3.5 hours and it's beginning to show. Okay. There we go. So we got sandwich. It is in there. Successfully added sandwich. We're up to 400 vertices too. That's getting pretty high. We will want to look at that in the future. Okay, let's go back. Let's see, what was I doing in player? Sandwich. Sandwich. Well, that's definitely in there. So why is this getting us a null mesh? Oh, wait, yeah. We added sandwich. This is definitely sandwich. Let me copy that. Copy. Let's go to player controller. Paste. I'm getting mesh sandwich. Should be correct. Okay, we've definitely got sandwich there. Let's run this again and see what happens. I wonder why it's getting null mesh. Let's see. Let's put a breakpoint here. That's probably what I should have done the first time. Okay, let's put a breakpoint here and see what we're getting for our mesh. So we do that. We got all that. Go into here. Here. We hit the breakpoint. Let's go into here. Let's string. Okay, let's see. Mesh name is sandwich. What does meshes contain? Meshes. We have how many elements in here? We have 31 elements. No, we have 0 elements. Why do we have 0 elements in our meshes? This should add to our meshes, right? Let's just double check that. Okay, meshes. We have 0 elements. Okay, and then we do that. We now have 1 element. Okay, so that's working fine. And then once we get here, Sam, find will return an iterator, and you can get the value from it too. So you can have to call at in the if because it's static variable. Because it's static variable, That shouldn't affect, like, we shouldn't be losing everything. It's a static variable declared at, yeah, the scope of the entire thing. Is this getting called twice? Nope, just gets called once here. And yeah, I know this returns an iterator. I mean, yeah, I could do this. I just hate this syntax so much. It's stupid, in my opinion, because then you have to declare this variable out there and then do that, and then you can say second, and that's fine. It's just annoying to me, but yeah. We shouldn't be losing our meshes though, just because it's a static variable. Have no choice but to start dinner. Looks like Gabe is on a mission today. Yeah. Is it adding the mesh before you call init? That's what I'm wondering too. Is it? It shouldn't be. Maybe it is. I think you're right. And there's an easy way to check that, isn't there? Let's try that. I think you're right, Langors. And you are correct. Yes. Okay. I'll fix that in a minute. Let's just see if this works, I guess, real quickly. Player controller. Let's remove that. Continue. Well, I don't see a sandwich. That's not good. That's disappointing. We should at least... Am I getting still... Nope, no errors. But no sandwich. Let's see, what about here? Nope, nothing. 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 I'm wondering if my transform is wrong. Oh, wait, no, I never added projection. That's why. We still have to add the projection matrices and stuff. And we have a memory leak. That's not good. Okay, we'll fix that in a minute. Is the draw call working correctly? I think it is. I think we just don't have the projection matrices and stuff yet, which is what I said I was going to add, and then I got distracted. Yeah, mesh shader.upload. U projection. I think I have a camera in here. Yeah, camera. That. Do we have to calculate it though? Wait. Yeah, we do. Do we have a registry? Hopefully. No, I don't. That's not good. What is this camera? Okay, this is a... Okay. Let's do scene. I don't like this, but... Crumble app. Come on. We are doing that here. Where are we getting the registry from? It's right here. Okay. So we'll do that. Okay. Same thing here. And then view. Where's our view? Calculate view matrix. What do we need for that? Just registry? Okay. I think that's all we need. Let's try it again. Let's see what happens. Okay. Next step is to open render doc. Oh, there we go. We got a sandwich. It's working. We did it. It's a very ugly sandwich because we don't have any lighting. We don't have any of that stuff, but we can add all that later. Hey, there we go. We got some applause. Anonymous. Thank you, Anonymous, for the applause. Sweet. Okay, so we can render our models now, and if we switch this to another model, it should just switch the models that we are using. So if we go into our player controller, and we wanted to do a cube, that should be a cube now. I know, right? It worked almost first try. That is a rarity, guys. The past 2 weeks have been some pretty good weeks. I think it's because I haven't been working on this except for on stream. So, yeah. What a great sandwich. I know, right? It's just amazing. And now we've got a red cube, which is good. And then if we switch this to a stair block, it should give us a stair block. This is like entity drops, like, you know, like halfway there. This is the hard part, right? Just getting that stuff working. Not really. We still got the hard stuff in front of us, but yeah. Maybe it's just that sometimes you need to take a break. I do agree. And we're trying to draw a null mesh because of the stairs. Because that should be stairs. I do agree. I think it's good to take breaks, and I don't take as much as I would like to. I also think it's probably because, like, when I code on my off time, I tend to do the easier stuff and then leave the hard stuff for stream, which is probably backwards. I should probably leave the easy stuff for stream and then do the hard stuff. Yeah. But this is pretty good. Okay, so we could add like a scale to this, and then we can add scales, and then we can add like a rendered instance rendering thing, and then we can batch everything so that we draw at the end of the draw call, do one big instanced render draw call, and then we can draw our entities, and then we'll attach meshes to entities and get all that stuff working, and, you know, pretty good place. I think this is a good start for sure, though. Yeah. And if we want to, we could even do like res.point plus res.hit normal. And that way it's not interfering with stuff. It's good when things just kind of work like this, you know? Let's go full screen to revel in the glory of all this stuff, right? So now it's just going like to the right of the normal. But yeah, that's pretty good. Got our stair block. And we can now do whatever. We'll eventually get the textures and everything up and running. I don't feel like doing that right now. It has been 3 hours and 45 minutes. I think we've gotten quite a bit done today, though. We got the ambient occlusion fixed. Ignoring that. We got the ambient occlusion fixed almost. We got this thingy working, which means we've got the start to our now instanced block rendering, which is good. We can add in actual entities and stuff in the next time, hopefully. But yeah, full screen minus the header. You know how to remove? I do. I would just need to like launch this. We'll probably have to add like a settings option so that we can do check full screen in here or whatever, which is something that definitely needs to be added. So get around to it eventually. But yeah, this is pretty cool. I am happy with how much progress we've gotten. Set it to nighttime. Get some nice atmosphere, right? The blocks look kind of bright. Is it because, whoops, still gotta fix this bug. Set time 0. Yeah, it's because it's still kind of light out. Okay, that was it. By the way, is it working with Linux? Nah, I still gotta prioritize that stuff, you know. I think I gotta fix it on Linux. I've also got to fix the launcher because the launcher isn't working properly at all. So that's something that I've got to eventually work on. I've got it really close. It's just, it's so annoying getting like admin privileges and all that stuff. It's just like one problem after another. But I want to get it working with Linux. I also want to get a legacy version working that will like fall back to OpenGL 3.3 if you don't support 4.5. That way I can support more hardware. But yeah, soon give new content for your brother to make a YouTube video. That's the plan. I want to get like mobs in the game too. Like now that we have this, we're very close to being able to add in like player models and mob models and do the same thing that we're doing for this. That was the whole point of this. Okay. And then we can get animations and we'll have animated mobs and we can add AI. We're going places, guys. We are going places, okay? Is the current source code available somewhere? Unfortunately, no. I may make it a Patreon benefit from my main channel sometime in the future. I'm planning on doing that once I hit like 50,000 subscribers, launching a Patreon and stuff. And hopefully giving people access so that you guys can take a look at this stuff if you want. I don't think it's the best code too. I don't want to like go around making people think that, because it's not. Like, I know I could be doing so much better and stuff. So that's a whole nother thing, but possibly in the future sometime. Yeah. But yeah, it will be fun, specifically making the AI. Yeah, AI will be pretty cool. A-star, all that stuff, right? Anyways, guys, I really appreciate you watching. Great stream. We got a lot done. And I'll hopefully see you guys next week. Yeah? Sounds good. Maybe a refactor 24-hour stream. We'll see. We'll see. Anyways, guys, I will see you next week. Good to see everybody, and hope you all have a great week. Thanks. See you guys.